and then that lasted all of like 8 hours, you know, and then as soon as we share like one thing, it's like all over.
Mm-hmm.
So fuck it. I've got medicine. It's just he never takes shit for himself. Like, you know, I don't know why. It frustrates me because I'm like, dude, just take care of yourself. Like, it's like I've got shit for us. Like, just take it. And he's just like, no. I don't know if he's just trying to like save it for money's sake or if he just like doesn't believe in medicine. I know
Mm-hmm.
he's not pro. He's not pro sticking himself with things. So I know that he's got reservations.
Mm-hmm. So, do you understand why the apple falls towards the ground?
Oh man, the fucking ether. Yeah.
Then explain. Can you explain it to me? Why the apple chooses to do that?
I would consider, like, after I thought about this, I would consider the ether to be more like an atmosphere because it's everywhere and it's equally pressured. So it's not like a it's not like a liquid stream like I thought we were talking about before. It's like a liquid effervescent like blanket, almost like a cloud or like an atmosphere
But it's moving
that
through
keeps
you.
things.
According to the calculations, it must be moving through you right now at 11 kilometers per second.
Where does
Whatever.
it go then? Like, what does it go like forward and back, or does it just like cycle? Like that doesn't make a lot of sense because our Earth is like circular. So is it just like roaming through us?
Some of it goes into you, some of it goes into the atmosphere. Whatever it goes into, that's how it gives it mass. Mass doesn't exist without the ether flowing into something. When the ether flows into something and annihilates, that is how the ether endows mass onto you, onto earth, onto the moon, onto the air. Everything that has mass, it's because the ether annihilates itself when it interacts with it. It's also known that this is what scientists call the Higgs mechanism. They call it the Higgs mechanism. Anyway, it flows into you, and that is how you have mass, and it flows into the earth, and it just self destructs. As it flows into you, it self destructs. And it flows into the earth and self destructs. But some of it passes through you, some of it is swallowed by you. Like your body absorbs it, some of it, but most of it goes
Oh,
through.
somebody said earlier.
What?
I said okie dokie.
You don't care?
I don't care that much to be honest with you because like
Mm-hmm.
I just dude, I stopped caring about science when I was in school. Like the whole like do everything long-handed like math like shit made me like disdain it, and like now I feel like getting into it is like picking up in the middle of a really long anime. You know
Mm-hmm.
what I mean? It's like when someone describes their favorite anime that like you know how some people have been watching One Piece for like literally like 15 years or some crazy shit.
I don't
It's like
know.
when people
I never,
talk to me about like an anime
like
I've
one,
never seen before and they're super into it and it's
I've
been
never
years and
seen,
I'm just like, what?
I've never seen any anime. I barely know what the word means.
Yeah, so if I just started like describing the plot of something that I've been watching for like 7+ years to you, you'd probably be like mildly able to understand, like, you know what I mean? But like you'd be like mostly lost and you'd be like, how the fuck does this apply to me? Because like I just kind of decided when I was younger to like unplug from the real world. Like, I guess that could be considered a maladaptive coping mechanism. But I was just kind of like, well, the world's not real anyway, so I don't really give a shit about its laws, physics, or like whatever. And then decided I don't care. And I was only going to do the bare minimum so that I could pass my classes, and I was never going to think about math or science again. and I was just gonna listen to like the majority of people when it came to stuff like should you take that or like is that poisonous? Like you know what I mean? And
Mhm.
just kind of go off of like uh I guess herd knowledge or like you know what I mean? Like herd mentality. And I was just kind of like, that's good enough for me. Cause like I don't have a passion for this shit. Like it just doesn't ring my bell. And like when it used to, it was because I don't know, like I liked discovering new things at that point, and at this point, it's like it feels like if you make a discovery or if you learn something new, that people are gonna come after you, and like I just don't need the bullshit. You know what I mean?
Mhm.
And I know that people are like, why would anyone go after you specifically? But it's like, you know, first of all, there's many reasons. I don't keep my mouth shut and I'm seen many places. So, like, I don't like also like regular people have been hunted down by the fucking feds, the CIA, fucktwids, you know, like I don't put it past anyone to
Mhm.
just randomly be like, oh yeah, let's go stalk this person and drive them fucking crazy. Like,
Mhm.
you know what I mean? Like, not in like a schizo way, but just in like a way where I've had the awareness where I know that that happens to like average people. And sometimes it's just because of who they're connected to. And, you know, since my dad was like a staff sergeant, he was like big into like mechanical shit, like engineering, like planes, stuff like that. Like, I don't like poking the bear when it comes to like upsetting the government. Like I follow every fucking rule because it stresses me out. Um and my dad used to have like these PTSD rants like down in the fucking basement where he would tell me all this really unnerving shit. So I'm kind of just like I don't want to learn stuff. I just want to build a fucking birdhouse, which is kind of exactly what my dad was like.
Mhm.
You know what I mean? Like, because he was just so fucking sick of bullshit. And he's just like, the more you know, the worse it gets. And, like, you know, it's so true. And, like, anytime there would be, like, a political issue or, like, a problem with energy or, like, something I couldn't describe, my dad would just be like, yeah, we learned that, like, more than fucking 30 years ago. We have completely an explanation for it, and we keep it from the government because we don't want people to advance a certain level of like intelligence or whatever. And I'm just like, what the actual shit? But you know what I mean? It's just constant bullshit. And then he's like, we have plans on disclosing this, like, yeah, like, you know, certain years in the future, and they might pull the plug on certain shit. You know what I mean? Because it's changing all the time. Like we can find something out and then they'll be like, how do we break this to the general public? And then they plan for it for like over a decade. So
Mhm.
if you're like the average dude with like a telescope and you make a huge fucking discovery and you're just like, hey, I'm the first person to figure this out, you're actually like the 110th, and like then you put yourself in a compromised position.
Mhm.
So you get what I mean? It's just this is my Donald Trump phase where I'm just like, I haven't read the project. I don't want to read the project. I don't know anything about it. Like, you know what I mean? Like, I don't want to. And like, I'm cool with listening to other people because they put themselves on the line. They don't put me on the line. I'm just like a fucking audience member. And I can say that either makes sense or doesn't make sense. But like, I don't come out with like confirming random things, you know what I mean? Or like saying I
Mhm.
really believe something because like, I don't know. Like, I'm only allowed to believe what people want me to believe, I guess, and I've just accepted that reality. And since that's something I can't control, I don't really feel like figuring it out. Like, you know what I mean? I don't want to fight City Hall on like big shit.
Mhm.
I much more appreciate like psychology and philosophy because those are things I can control. Like, that's like between my ears. You know what I mean? Like, they can't take away what's in my head, dude. I'm free within my mind.
Mhm.
Physics can be a confining topic because we are physically like, you know, tethered to the world. But that's what I don't like about it. And like suppressing information is also fucked and scary.
Mhm. Mhm.
It's even worse when like people do this with like medical discoveries. that just makes me like even more depressed and pissed off. So I decided to stop seeing doctors like fucking years ago. I'm just gonna do my own research, and if I really need a medication, I'm gonna fucking, I don't know, order it on the internet.
Hmm.
There's so many like Indian pharmacies, like TikTok pharmacies now. It's like I don't need people's bullshit.
Hmm.
I do think it's valuable just to learn about quantum physics because there are so many people who like, I don't know, falsely teach about it and kind of try to use it to convince people of shit or like brainwash them. So like that's not cool. Like rather people know about it and be able to answer their own questions. But like, you know, I don't need to know exactly how the apple falls. I just feel like a broad understanding is okay.
Hmm.
Oh shit, it is raining. It's like one of those fine mister rains. If I go out, I'm gonna get soaked. I can see it. It looks like a sprinkler came out of the sky. You okay?
Yeah. Um. I'm trying to write the paper that I just started explaining to you. I need to write it like in a paper form so that somebody can just read through the explanation.
Maybe you can take excerpts from your like YouTube video. Like you can go through the transcriber and just copy and paste some of what you said out loud and then revise it with like Grammarly or something.
Yeah.
That's what I would do. I would either revise it with Grammarly or ask ChatGPT to revise it.
Hmm.
Maybe get the free 1 month subscription to that or something, and then just do all of it at once.
Hmm. I'm thinking, like when I worked on the first paper, it was really easy because I just did diagrams. So maybe that's what I should do. Just diagram after diagram after diagram. Just do the diagrams. Diagrams are easy, and then
Yeah, I could.
I can write an explanation to each diagram. That and then like people understand diagrams better than they understand words.
That's true.
Words don't
But
come
yeah,
in.
you can write it like it's a PowerPoint
Yeah,
presentation instead of
yeah,
just a paper. That'll help people understand it a lot.
yeah, yeah. I agree. Do you want to help me?
Yeah, totally. I'm good at writing.
So can you join me on? I'll give you the link so you can join me on StreamYard instead of Discord.
Okay, do I need to make an account?
No, no. I just give
Okay,
you.
cool. Easy.
I'll just give you a link.
That must be where you're always talking to these other people, right?
Yeah.
Cool.
So you click on the link with TM, the BTM at the end. The one that
Awesome.
yeah.
Should I disconnect here?
No, no. Only after I'll hear you twice,
Okay.
so I can see that you're coming on the backstage. Tell me what you're
So let's
seeing.
continue with YouTube. We'll do that. Continue with YouTube, choose account, continue, and it should be fine.
Words don't come easy
Okay, I'm just trying to allow
to
access to stuff. It says
take.
headline optional.
It says what? Oh, there
I
you
got it. Okay.
got you.
Now, how do I turn off
I
that? Okay,
turned it
cool. I
off.
got
I
that
turned
off.
it off. Yeah.
Thank you. There
Don't come easy. Okay, so now I'm not hearing you twice, so you don't have to disconnect from Discord.
I minimized it so I couldn't hear you either, but as soon as I
Hmm.
expanded, I can hear you twice too.
Okay, okay. Anyway,
So
so
should I just disconnect from Discord or?
it doesn't matter if it doesn't bother you or nor me, then it's fine. So, so this is the paper. No, it's not. This is a different paper. So this is the paper that I just start. This is why does the apple fall from the tree and accelerate towards the ground? So maybe we should. Now I heard you twice. So let's add a diagram that the apple. Let's add an insert an image. No, a table drawing. Do you know how to use like Google Docs? That's amazing. I love it so much. Don't. Hmm. So which of these is the best to use for an apple? Like just a circle? 'Cause- No, no. I mean that's good. I'd rather not. I'd rather use like only the built-in stuff. We could use the moon to ask why is the moon. That's like the next step. But let's. Hmm. Where's the apple? I asked it for a circle. There's an apple. You want to make it red? A red apple? But look, there's no real red. It's not really red. It's not tingy red. It's like matte. Green? You want a green apple? Okay. All right. There is the apple. Now we need the ground. Let's add the ground. The wait, what? Oh, really? Wait, did it stop? Oh, I never shared it? I never shared the This happens so much that I'm not sharing the right tab. I'm sorry. Wait, I can't hear you. What? Hmm. Yeah, I do. Yeah, I mess it up a lot. Anyway, here is the apple. Now I'm gonna add the ground. Now the ground is just a line. So I'm just gonna add a line. Just a line. Yeah, just a line. This is the ground. But then we need a few more lines. The ground usually we denote with three lines like this at 45 degrees. Do you know this song, Words Don't Come Easy to Me? Really? Words don't come. Oh, wait, I can't hear you. You're like totally muffled. No, it's no, no, it's mostly fine. It's mostly fine, right? Like most of the time I can hear you perfectly well, but sometimes you're muffled. Like I'll tell you whenever you become muffled, I'll just let you know. I need to separate the distance between these guys. Um, okay, something like this. So this is the Earth. Let's have a call out. I use call outs. I use the simple. I think this call out, the simple. Maybe I'll use this guy. and I'll make it transparent. Where's the transparent? There's transparent. Okay, this is the earth or the ground. Words don't come easy to me. Dee la 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 dee la la. So you never heard this song in your life? I don't believe it. Let me find it. I mean, everything is before everybody's time. Words don't. See, I just put the word words and it auto completed words don't come easy. Introducing. One second. It's an ad. It's a very, very long ad. Do you like vegan gains? Here, listen. No, I think he's no, he stopped with antipsychotics. Here, listen to this song. Let's listen to this song. Can you hear it? Okay, we're done. I don't want to get the strike because every time I play a song, they give me they don't give me a strike. They just like they send me notices and they ban and they block. So it's too dangerous. Anyway, it's a beautiful song. You should definitely listen to it. Words don't. Okay, let's continue. So this is the ground. This is the apple. Maybe we should have an apple tree. Tea, dee, la, la. No, I don't think we should have an apple tree. Should we have an apple tree? No. And the question is, why does the apple, let's put an arrow. Li, li, na, 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 na. Li, na, 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 li, na, li. And we'll put a question. So why does the apple fall? Why does the apple fall? I'm just thinking, am I correct? Is this the correct explanation? Because Einstein gave a different explanation, but his explanation is not mechanical. I don't. Anyway, so let's have another call out. La, li, la, 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 ti, la, 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 la. Why does the apple why does the apple fall? Fall slash accelerate. To accelerate, we need to make it bigger. Accelerate towards the earth slash ground. Okay. This is step one, but I need. Mm-hmm. but I needed to have like in the other papers that I did a diagram. See, there's this pinkish. Oh, I added a pink rectangle. Okay, so let me copy it. Mm-hmm. Oh, it's too wide. I didn't know that can happen. Let me see. Control 0. Okay, it's too wide. I think that should do it. Still? It still misses the edges? Wait, why can't I? Oh, okay. I need to move it to the back. So order send to back. Okay, a little better. So why does the apple fall? All right, the next step is going to be, we need to, can we copy this? Copy. Are you watching? Are you there? No, that's impossible. Oh, you dropped out. Wait, how can I hear you? Wait, so I'm hearing you on Discord? That's not good. So maybe no one else can hear you. Let's see if I can hear you. Let's open the YouTube. Let's see this. I'm gonna see the stream on YouTube. Let's see if I can hear you. Let's open the YouTube. Let's see. Let's see this. I'm gonna see the stream on YouTube. Let's see if I can hear you. No, we can't hear you. Count to 3. Let's open the YouTube. Let's see. Let's see this. I'm gonna see the stream on YouTube. Let's see if I can hear you. No, we can't hear you. Count to 3. Let's open the YouTube. So so th- so they can't hear you. Wait, is it telling you that you don't have permission or something? That it wants. Let's see. Let's see. Well, I can't hear you. I mean, let's see. 1, 2, 3, 4, well, 5. I can't hear you. See, I can hear myself, but not you. Let's see. No. 1, 2, 3, 4, well, 5. I can't hear you. See, I can hear myself, but not you. Let's see. No. 1, 2, 3, 4, well, 5. I can't hear you. See, I can hear myself, but not you. Let's see. No. 1, 2, 3, 4, well, 5. I can't hear you. See, I can hear myself, but not you. Let's see. No. 1, 2, 3, 4, well, 5. I can't hear you. See, I can hear myself, but not you. Let's see. No. 1, 2, 3, 4, well, 5. I can't hear you. See, I can hear myself, but not you. Let's see. No.
1, 2, 3, 4. Well, I
You can
can't
fall
hear you.
asleep
I
to
can
this,
hear myself, but not you. No.
but we can't hear you. We have to fix this. So you want to exit Discord and try? Okay. Words don't come easy to me. La da dee da da dee da 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 da. Words don't come easy. Okay, we're waiting for Amber. Meanwhile, and in between time, meantime, in between time, let's continue with this. Okay, so the apple is accelerating. Why is the apple accelerating? So we don't need. So we no longer need to say Earth and apple. All right. Okay, I'm hearing something.
Okay, can you hear me? Because it says everyone can see and hear you now.
Yes, I can hear you. Um, let's. Yes,
Okay, finally, I can hear you.
hear you. Very good. Excellent. Anyway, so this is the next. This is figure 2. So the other one is going to be figure 1. So this is going to be figure 1. But maybe we should name it externally. Like we should say here, figure 1.
You can just put little like text on the figures, like 1A, 1B, 1C, and then just in the bottom you can
What?
you can label them and then explain them in the bottom. So that's not so much text and lines.
Well, wait, what are you saying? I can write the text here that explains figure 1. Like I could name it here.
Yeah.
I just don't. I honestly, it's a little bit of a problem because then things start moving around. So
I thought it
let's,
would make it more clear, honestly.
if we do the text externally, I think the best thing is to add the explanation here that this is figure 1. Let me add a square. So this is just going to be like not a square. I mean a rectangle. Like here. I'm just going to say, let's make it transparent. And here we're going to say figure 1. Oops. Figure 1. And that's it for now. I mean, figure 1 doesn't have anything else exciting to say. So we can make this maybe even smaller and put it like over here. So for now, that's going to be it. And now let's go to figure 2. This is going to be, let's maybe take, I'll just take this with us, copy this. This is going to be figure 2. Okay, so in figure 2, we're going to introduce the ether. So we're just going to have an ether fluid flowing, and that's it. I don't know what else to do. Like the question is, should I use like these arrows, like a bunch of these arrows?
I would do like a curvy waved line.
But like, The point is, I want to say that there is a fluid flowing through. I don't want this line, so it can't be transparent.
Hmm.
Maybe it should be transparent. Maybe we should see the Earth. That it's going right through the Earth. This is actually the point. Okay, let's put a few of these. Just want to make sure the distance, they're equidistant. You never thought you'd use that word.
Mm.
Equidistant. Figure 2 gets in the way a little bit. Okay. So we need a call out to explain what the heck we're trying to say here. But basically this is it. I mean, this is the beginning. This is just the beginning. This is not the end. Things will never be this. Do you remember the song "Things Will Never Be the Same Again"?
No, I don't know any of this music. I don't know where you got this from. You have like alternate dimension, like radio.
This is just the beginning. This is not the end. Things will never be the same again. Anywho, so this is the ether. Maybe we should give the ether a color. Maybe the ether should be blue. It's like a fluid. So maybe it should be blue, 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 blue. Is this blue? Light cornflower. What? Cornflower. Dark cornflower? Cornflower is blue?
Yeah, cornflower is like a light blue.
Really?
Yeah.
Cornflower blue. Look, it's like blue. It's like blue eyes. Okay. So can we just take this color and bring it over to this guy? I think we can mark the rest of them. Even.
Yeah.
And then I think it's the cornflower blue. Okay. And now we're going to say this is the ether. This is the, should we call it the gravitational ether?
Yeah.
Gravitational. This is the
Unless you don't want to
gravitation.
use the word gravity, because aren't you trying to disprove gravity? Maybe you don't want to use that.
No, I'm not disproving gravity. I'm explaining gravity. Gravity. I'm not disproving gravity. I'm not disproving anything. I'm just explaining. This is the gravitational ether. It is a fluid that flows into or through the apple. Well, okay. That flows into the earth, into the ground. Earth. Okay. So that this is the ether. We can point at this or this. And we could say that it's going through the apple and it's dragging the apple I
You're getting
hate
a
it.
phone
I hate
call.
it. Yeah, no, I'm shutting it down. So I hate it when I try to close the phone and it takes a snapshot instead.
I heard that. I was so confused. I thought I did it. I just got up, so I was like, "What the fuck?"
Uh, um, um, let me just take a message that I never forwarded. Let me see. Let me take this, copy it here, and this, copy it here. Let's go. I need to send this message to this guy.
Vegetables. Blue. Mom.
1 second. So 1 is this. 2 is this. 3 is this. And 4 is this. Let me just, yeah, something like this. All right. All right, let's continue. So this is one call out. The other call out is that this fluid flows through the apple and drags it down, obviously. And this, basically, this is going to be it. And I need to number these things. So this is going to be 1. And this will be 2. But why is this? Why is it? Like this? Yeah. And this guy like this? Wait, what? No. 2. Why doesn't it? Oh. I don't get it. I never know how these things work. No. No. So 1 like that. 2. So at, as the gravitational ether flows through the apple. Ether fluid flows through the apple. It flows through the apple and it drags it down towards the earth. So it flows through the apple. And then we need an arrow. We need to get back the arrow that the ether that the apple falls, accelerates, whatever. Yeah, we need to make it green. Let's make the acceleration green or greenish, or I don't know. There's only one green. There's no greenish. What's this? Paint format. There's nothing else. Border dash. Border. This is just border. So the fill, you cannot do anything with the fill. There's only one type of fill.
Cheap.
But there's another type of arrow. There's this arrow and this arrow. Oh, look, it's pinkish. It's beautiful pink. Can we rotate it? No. We can't rotate it. There's no way to rotate it. Can you believe it? It's only right and left. Arrow. So I don't believe it. That's impossible that I can't rotate. Oh, there it is. Okay. Okay. So what? I think it should be pinkish. Okay, let's make it pinkish. So this guy is going to be pinkish. Let me get rid of the other one first and then add this one. No, it has to be filled because it's going to interact with this guy.
Hey,
Yeah.
I'm opening more baby carrots.
Baby cake?
No, baby carrots.
That's good.
Probably gonna make soup.
You're going to make soup?
Probably. Yeah.
Awesome.
It's good weather for that. It's like shit out.
I can't hear you. What? What? It's cold outside?
Yeah.
That's awesome. I love the winter. Words don't come easy. Okay, 3. As the. Okay, I'm going to stop calling it gravitational ether fluid and just call it ether. As the ether flows through the apple towards the ground, it drags. One second, I have a message. Okay. As the ether flows through the apple towards the ground, it drags the apple towards the ground with it. Does that make any sense?
Yeah, but it looks like a circus.
It looks like a circus?
Yeah.
What do you mean, circus? As the ether flows through the apple towards the ground, it drags the apple towards the ground along with it. I don't know if we know what it means. Maybe I should say along with the ether. Words don't come easy to me. What do you mean? It looks like a circus. Is it a good circus or a bad circus?
It looks like an Israeli circus.
Thank you. What are you talking about?
Because of the colors.
The colors? Well,
Yeah.
blue is because it's a fluid, and green is because it's an apple, and pink because that's like I'm gonna go with the effect of the ether as pinkish. I don't even know. Is it pink or purple? I think it's pink, right?
The Native Americans believe it's like turquoise.
Purpleoise. La 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 la. Okay, that's figure two. The next figure, I think, is going to be the moon. Let's do the moon. Let's ask the same question we're going to ask about the moon. Are you ready?
Yeah.
Are you ready for this? Are you ready for this? I don't know. Do you know the song? I don't know where the bullet streaks. Do you know
No?
this? You
I'm
don't know this?
convinced you're just like making up shit.
No, that's Queen. Another one bites the dust. You never heard of Queen's Another One Bites the Dust? Words don't come easy to me. Yeah, da dee da da dee da 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 dee da da da. Okay. So back to figure one. Let's ask the same question. I think we should ask the same question. Let me just change the title. So the title was Morning Coffee with Amber. So it's going to be writing a paper about gravitational ether. Drawing diagrams. Ti da 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 na 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 na. So where were we? We was here. So I think the next step should be the moon. I don't see why not. Let's do the moon. To the moon. All right. So and this will be figure 4. Figure. Wait, 4? No, 3. Why do I think it's figure 4? Figure 2, this will be figure 3. Okay, figure 3. So we're going to need. Really?
Prescriptions. Okay.
What?
I'm sorry, I'm taking the pill.
You're taking the pill? What?
I'm taking like my medication.
Oh, okay.
I just ate breakfast, so now I can finally take them.
Words don't come easy to me. So this is going to be the moon. What color should we make the moon?
Gray, definitely.
Definitely. Let's see. There's many grays. There's dark gray, very dark gray,
Like a
very
lighter gray.
light gray.
Yeah, you can do some other dark gray circles and put them like inside the circle so it looks like craters.
It looks like a crater.
Yeah, so it looks more like the moon. It's more straightforward.
And I don't want to invest too much in these drawings. I mean, it's supposed to be a
But you brought me
technical.
here for artistic like consultation, so
Oh, okay. So here is the moon. The moon. Did you know that the moon actually has a name? The name is not moon. Moon is a noun. It's like a chair. Like you're not gonna say the chair. Like you could say, but you could say a
yeah, because
chair.
there are other moons on other planets. Like I get what you're
Yes.
saying. Like so
So do
there's
you
like
know?
multiple moons on like Saturn or something.
Yes.
Or
So do you know?
Venus has like multiple moons.
Yes. So do you know the name of our moon? It actually has a name.
No, I don't.
It's actually called Luna.
That's cute. That must be where we get that from.
Where do we get it from?
Because like people use that just to say like moon. I think it's just moon in other languages.
I think it might be from Arabic.
I thought it was like Mayan.
I don't know. Like the word loony, like you're crazy. It comes from moons. Like you're moony. Like you're like
Yeah, like the moon's controlling
yeah,
you.
yeah, yeah,
Because they thought that about like basically every folklore monster, you know, like vampire, werewolf.
yeah,
Thought people's general sanity was controlled by the moon.
yeah. So this is going to be the Earth's moon, and we're going to ask the same question: why does the moon fall, accelerate towards the Earth? Wait, what is the? There's like a greater than sign. And we didn't put it. Oh, it was supposed to be a question mark. Why does the moon fall, accelerate towards the Earth? So we need the Earth. Let's make the moon maybe a tiny bit smaller. Because we need the Earth to be bigger. What color should the Earth? What color should the Earth be?
Blue, like us. We're a big blue planet.
We're a big blue pointless planet. But the Earth, I think, is like much bigger than the moon. The moon is like tiny compared, isn't it? Or is it big compared to the Earth?
I'm really not sure. I think the moon is like a fraction of our size.
Let's ask ChatGPT. What is the size of the moon compared to Earth? Oh, that's not even ChatGPT. That's other GPTs. So the moon is significantly smaller diameter. The moon's diameter is about 3,400 kilometers. It's about 27% the Earth. Oh, it's a third. It's not that smaller. It's basically the same size.
Yeah, like if it crashed into us for any reason, I think it would fuck us and we'd all die. But like,
Probably. Okay, here is the third. Okay, so this is the Earth. This is the Earth, my friend. Do you know the song This Is the End, my friend? 1 second.
I think I know that song.
That's Oh, this is the end, my friend.
I'm pretty sure I know that song because it's just in a movie. I saw.
Beautiful song. There's so many beautiful songs. I wish we could play them in the background. Unfortunately, we're not allowed, but we're allowed to play. You know, I have background. Oh, I didn't go. I forgot again to share the right tab. But let me play background music on StreamYard. Okay, let's see this. 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 Okay, let's see this It's very good. Dance pop. That's also nice. They're all nice. This is
This calm
great.
one's not bad. Yeah.
What?
This one's not bad.
Yeah, it's good. I can control the volume. Let's make it 1/4. Okay. So we're like a professional stream.
Now we are, yeah. Now we got a studio production.
Very nice, very nice. Okay. So the Earth's moon and the Earth's moon. No, this is the Earth. It's our Earth. Do you know the song Our House?
Yeah, I know that one. That's
Oh,
from the Folgers commercial, yeah. Or Maxwell House, whichever one.
a commercial
It's from a coffee commercial, yeah.
in the middle of a street. Our house. That's the place we used to live. Okay, bring to the front. Okay. So why does the moon fall, accelerate towards the Earth? That's a good question. No one has tackled since Einstein. Okay, so now we're going to go to figure 4. So this will be figure 4. So figure 4 explains the ether flows through the moon into the Earth, my friend. So we're gonna need the ether lines. Let's take the ether lines from this guy so that they're as similar as possible. And we need to rotate. Well, let's make them smaller, much smaller, because we're gonna need to point them basically like this towards, well, they're gonna need to all meet at the center. Okay. This is not gonna be easy because we need to rotate. We need to let's have let's start with just 4. It's kind of artistic.
It looks like one of those religious things where it's like, yeah, like a schizophrenic thing. It's like, this
Oh
is
my
what
God.
we're gonna put a guy in the middle of, and we're gonna light a tiki torch.
Oh my God. Okay, we're gonna need to create 4 more. So I'm gonna create all 4 at once and rotate them all at once. Let's see if I can do that. Let's try and rotate them all at once. 320 degrees. By how many degrees? 315? What do you think?
Are those the only options?
I think it's 315 sounds about right. I don't know.
Okay,
I don't know.
go for it.
But I'm gonna make them all just a little bit smaller because I'm seeing an issue. How do you make them smaller?
Just, yeah, that's what you do. Click and drag.
No, actually, I need maybe to make them bigger. No, it's a problem. I'm gonna have to do them. Let's do Control Z, Control Shift Z. Yeah, we're gonna need to do this one by one, or maybe two at a time. No, it's gotta be one by one. Yeah, they can't be, or unless we make them much thinner. We're gonna lose the effect. They're gonna have to be like, they can't be close to the center because then they start touching each other in inappropriate ways.
Wow.
Yeah, definitely. Yeah, the arrows are known to be inappropriate, to behave inappropriately. How does it look?
I get what you're going for.
Okay, so this is the Earth and this is the ether, but the arrows are all different. They're not the same. Like, you see the problem. Do you see a problem? I don't even know if I'm seeing a problem. I don't. Anyway, it's very difficult. Okay, so this is the ether. So
I'm gonna have to go because my friend called me, and I'm gonna call him back
Okay.
and see what's going on.
Okay, I'll see you later. Thanks
Yep.
for hanging around. Come back later. All right. So this has to be on top. Order, bring to front. So this is the ether. This is the ether. Flowing into the Earth. But the trick is that it's flowing through the moon. That's the whole thing. Now that's the real trick. See, it's flowing through. Okay, so we need to make them all much longer. Can we do that? I don't think so. Yeah, it's impossible. We need to make each one longer. No, that didn't work. And this will point here, and this can be smaller. This is the ether flowing into the Earth, but it's flowing through the moon. So we need to number. So this is the moon. This is the Earth. This is the ether flowing into the Earth. And now I'm going to say this is the ether. So we need to move this away. Let's put this here. And this will be the ether This will be 4. The ether flows through the moon, dragging the moon into the earth. So I just want to make it a little bit more symmetric. But then they're not going to understand why there's this asymmetry. So this needs to be, they all need to be the same length. I'm just wondering, like this? Is it really important they should be the same length? But if they are the same length, it's not going to reach the moon. No, it's not going to reach the moon. What if we put this... I have an idea. Okay, this we'll put here. We'll... It's difficult to select everything all at once. So I want to select this thing, but without this, without this, without this, without that. So I think like this, like this. Okay. Like this. And then this could be over here. Now they can all be the same length. Can I tell them to be the same length? If I select all of them. And can I tell them to be the same length? Align, distribute. I want them all to be the same. Align, distribute. Horizontally, vertically, group. No, there's no way I could do that. No, that's not what I want. Okay, it has to be just approximately the same size so that no one gets confused why. Like, it has to look like it's the same size. How can I measure? What is the size? Impossible. We don't have... There's no tools for this. There's no make same size. Okay. So this can fit here. This is the ether flowing make it smaller. And the ether flows through the moon. Where would that fit? The ether flows through the moon. The ether flows through the moon, dragging the moon into. So this is the drag. So it's a separate call out. So the ether flows, that's one thing. And then the ether drags. So I don't know if we need this. So this is going to be the drag. Yeah, it's going to be very difficult. So this is going to be 5. The ether drags the moon towards the Earth. So that's 4. So 1, the Earth's moon. 2, the Earth. That's from last time. 3, this is the ether flowing into the Earth. 4, the ether flows through the moon. 5, the ether drags the moon towards the Earth. Okay. So the next step is to explain that the ether flows, right? The universe is filled with the ether and it flows into galaxies. The next step after that would be it flows into galaxies. The next step is, well, very quickly the universe should run out of ether. So we need a fresh supply of ether. Therefore, there must be dark energy, or the lambda in Einstein's GR, that resupplies ether and creates a positive pressure. And the annihilation of the ether creates a negative vacuum, and then there is a pressure gradient, and that causes the flow of the ether. This is a very nice theory. It's really it's a very compact and complete and mechanical theory. It's really very scientific. I'm really amazed by it. The question is, does it fit I mean, I need to put it through the rigor of the peer review process to see what other people think, what the experts think. Okay, so this is 4. This is going to be 5. 5 is just going to be the universe. This is now going to be the universe. So let's get rid of everything, basically. Or maybe we should have a galaxy, and then I guess we could have a galaxy. The universe. Yeah, we maybe we should show a galaxy, but then we should show that the sun. Yeah, we could just show a galaxy and look at a single star in the galaxy. So this would be a galaxy. And there's ether flowing into the galaxy. The galaxy doesn't have so much of a center. What gets attracted to the galaxy? Maybe we should have shorter lines because they're taking up too much space. This is not so much centered. Is this 5? This should be smaller. But what is this? I don't know what this is. So this is a galaxy. This is a galaxy, and these are it's one. This is a galaxy. And this is the ether. This is 2. Flowing into the galaxy. As it flows in, it drags in. We should put a star here. I don't know if we need to do that. I think it's clear at this point. Is it 5? Yes. So this is a galaxy. This is the ether flowing into the galaxy. Obviously, it's holding it. The ether flow holds the galaxy intact. So we can put like small gravitational. We're using the gravitational thingy. There's no Control Z. Let's take this from here. Copy. So we should have a bunch of these, like really tiny. Wait, is this what we're using? Didn't we change it to something else? What's going on? Didn't we change it? What's going on? Yeah, it has these lines at the back. Apparently they disappear when you make it smaller. Okay. So we should just show a single like put a little star system here and show that it's attracted. It's going to be too small. Forget it. Okay. So this is 5. The next step is 6, and that's going to be 6 should show that very quickly the universe should run out of ether. So let's take 5, copy. This is going to be 6. So this is going to be a bunch of galaxies. We should make it's going to be very tiny. Actually, I should put this here and maybe get rid of a bunch of arrows. There's no room for all these arrows. And just make them really tiny. Because I want to have a bunch of galaxies now. Make this tiny. Move it in. No, it's too much. Now we just need a bunch of them. Maybe we should group them into one unit. So now we're going to have many of these things. Oh my god, I'm gonna lose my mind. So paste, now I wanna move it. But keep the distance. Okay, call out will stay out. So this is the universe. So we should say this is the universe. So we should fill it with the blue. It should be filled with the blue. Is this the blue? That was weird. Oh, this is the blue. Send it to the back. Order back. This is the universe filled with the ether. And this is a galaxy. There's ether flowing into the galaxy. It's the cosmic ether. This is the ether flowing into a galaxy. And then the question, is this figure 6? 5, 4, 3, 2, 1. And by the way, there should be a question mark here. Okay. Why is this starting here? Maybe like this. Anyway, this is 3. So 3, this is the ether flowing into a galaxy. And the question is, well, it's not a question. The universe should be collapsing on itself. Why isn't the universe collapsing onto itself? So let's select everything except for the outer. What? Except for the outer and except for this. Move it. I want to move it up a little bit so I can ask a question at the bottom. Like this. So this guy needs to go down like this. So this is the universe. Oh, that's fine. This could be like this. This is the universe filled with the ether. This is a galaxy. This is the ether flowing into a galaxy. And then the question is, so we should place this here. Like this. We should ask, this is going to be 4. Why? Well, the universe should run out of ether. And collapse onto itself. The universe should. But this should be like a hazard. So we should change this shape to like. Change shape to like a call out. So there's call out, explosion. Explosion is a call out? So we can't point, doesn't have a pointer. Yeah. So maybe we should just make this red. Like hazard. The universe should run out of ether and collapse onto itself. That's 6. So the reason it doesn't is because of dark energy. So this is going to be 7. This will be dark energy. Let's change. Feeding the ducks. Into space. I mean, any one of these music backgrounds is terrific. I love them all. Rock. Night driving. Oh, that's good. Okay. Let me check the audio. Is everything fine? Check the audio. Is everything fine? Yeah, sounds fine. That's good. Okay. All right. So this is dark energy. So there's always a positive pressure. So the answer is dark energy. Dark energy creates new ether. And it causes the expansion of the universe. Didn't we send this to the back? Okay. I need to select them all separately. Wait, I don't want to. No, I don't want to do that. I want to just make this bigger. And pull these apart. Let's get rid of this for now. These are pushed to the side. Anyway, but what we need to show is the creation. So we need to show the creation of more yeah, we need less galaxies. Let's take just a few. I don't need all the galaxies. We made the point. Now we just need. Let's take any 4 galaxies and just show that there is dark energy. So what kind of shape are we going to add? Let's see, arrow. You see there's this arrow. So maybe we should put a galaxy here. Let's send this to the back. Oh, so where is the other one? Wait, these were never grouped? So bring this. This is at the top? Maybe it doesn't have any color. It is? It's blue? What blue? Cornflower? So why can't I see it? Why can't I see it? Oh, maybe no, it's blue on blue because it's blue on blue. Okay, so let's. This is dark energy resupplying. So let's add a call out. This is dark energy. New ether is spontaneously being created. This is dark energy. New ether is spontaneously being created. Spontaneously is too wide. This is dark energy. New ether is spontaneously being created all the time. And it creates a positive pressure. So just the creation is here, but it creates a positive pressure. Dark energy creates a positive pressure, causing the galaxies to accelerate away from each other and expand the universe. Dark energy creates a positive pressure, causing the galaxies to accelerate. I would say accelerate apart instead of all these words. And expand the universe. Okay. Okay. Now getting back to the nature of the ether, it annihilates when it impacts on massive particles. So let's draw it next to an electron. This is going to be 8. So this goes away. Okay. So we're going to have an electron. This is an electron. An electron is a wave. It's not a particle. But it's fine. This is an electron. That's the problem with text inside a box. You have to resize things based on the text. That's no good. Okay, this is an electron. Now we're going to have the arrows. The ether flows into it and annihilates. So let's have one of these arrows. So this was going to be the ether flowing into an electron. I'll have a bunch of these. We need a call out to explain what's going on. Okay, so this is an electron. This is the ether flowing into an electron, or into the electron. So this is the ether flowing into the electron. But it annihilates during this interaction. So we need an annihilation. So it should be over here, and let's add an annihilation. There's no explosion here. The explosion is a call out? Maybe we should have a lightning. Or a bubble. A cloud. Let's try to have an explosion. So this is the ether flowing into the electron. This should be at the top. So this is 3. The ether self annihilates upon come on annihilates double N annihilates upon interacting with the electron. The ether self-annihilates upon interacting with the electron. The ether self-annihilates. And when it self-annihilates, a vacuum is created. So this is going to be figure 9. We don't need this. Like this maybe should be maybe yellow. Like it self-annihilates. Okay, so it self-annihilates. So now an ether vacuum is instantaneously created. On the ether self-annihilation, an ether vacuum is created. So there's an ether vacuum, but outside, everywhere else, there is no ether vacuum. Everywhere else, there's plenty of there's positive pressure. So we need we need to fill the background with a cutout, like a cloud maybe. Like we need to fill the background. The background should be, well, let's send it to the back first. So the background should be, is this the blue? That's a nice blue. Wow, colors are so beautiful. Yeah, but we decided that this is the blue of the ether. So let's no, wrong one. What's being moved? Oh, the box. What's going on? Come on, stop. I can't grab it. Oh, this should even be in the more in the back. So this can be here basically. Mm-hmm. So here there is positive pressure and here there is negative pressure. So you get a gradient of high pressure to low pressure, and that creates the flow. So upon the ether self-annihilation, an ether vacuum is created. Okay, that's step one. Step two is that this is a low pressure. This is now a low pressure, a low ether pressure air zone, low ether pressure zone or area or volume or, well, it's a zone. So it's a low ether pressure zone. Yeah. But outside, it's a normal high pressure. Here is a normal high. What's going on? Ether pressure zone. So now you get a gradient of high pressure to low pressure, and therefore you get a flow. Maybe we should make this smaller. Whoa, what just happened? How did that happen? How did it just rotate? Wow. Like I touched something and it just rotated. Like I touched... I don't even know what I touched. Mm-hmm. Okay, so here is a normal high ether pressure zone. So now you get a gradient of high to low pressure. Can't. Gotta move this to the other side first. This actually has to be here. So this is going to be that a gradient. How do you show a gradient? the arrow with the trailing tail. That's going to be completely pinkish like this. I wish I could. It has this nice back. Maybe I can play with it. Is there any way to play with the back? No. Impossible. Anyway, so we have now a gradient. An ether pressure gradient forms. Yeah, but this has to be front. So an ether pressure gradient forms. This is the pressure gradient. I want to show that there's a pressure gradient here. How do I show a pressure gradient? Because this is already this is the ether flow. This causes the ether flow. This could be the pressure gradient from high to low pressure. From high. Anyway, I've already explained it. I mean, I think it's clear at this point where's the high and where's the low. Is this not on top? It's on top. So why can't I see it? Oh, it's the same color. Anyway, that's the pressure gradient, and it causes the pressure flow. So this brings us to the beginning. In the beginning, we just said there is a pressure, that there is a flow. We never explained why the ether flows. We just asserted that the ether flows. But now finally we're explaining why the ether flows. The ether gradient, the ether pressure gradient causes the ether to flow from high to low pressure. Now you understand why the ether flows. Until now, we didn't really understand why the ether flows. And this completes the circle. This is the circle of the life of the ether. That's it. That's the whole theory. That's the theory of the ether. That's how it works. This is quantum gravity. Notice this is quantum gravity. So where is it? This is quantum gravity because this is an electron. So whether we like it or not, we explain quantum gravity on the way. So this is basically GR, quantum gravity, lambda. Mm-hmm. Well, we should make a point that this is quantum gravity. It's like this is gravity at the quantum level. Okay. Let's see. So let's see this. Let me just shut down the background music. Actually, it doesn't matter. Maybe we should switch the background music to Lo-fi. I don't know what Lo-fi is. Let me see what they're talking about.
And on the moon, that's kind of taken to 11 because there's nothing there other than just, a whole bunch of dust and rock.
Well, and the Nazis, of course.
Obvious. They're on the far side. I'm sorry, the dark side of the moon. Yeah.
Oh, hey, Mr. Slave, how's it going?
Hey, terrific. How's everyone?
Good, good. We were just talking earlier. I had a debate yesterday about Hawking radiation and cosmology. So
Hawking radiation and cosmology. Okay. So what's your opinion on Hawking radiation?
that it is potentially real. But I don't really know that much about it. But the person I was debating against was trying to say that it's not reality and it's just math that doesn't exist. And I said, well, that might be the case, but we can't know for sure.
Right. I mean, we can know, but not. I don't see how we can know today. I mean, we can send a probe to a black hole, but it would take even if we would send it at near light speed. So for us, if we sent a nano probe at near light speed, as far as it's going to still take thousands or hundreds of thousands of years. Where's the nearest black hole actually?
The center of the Milky Way, I believe.
No. They're much closer. Let me check.
Yeah. I mean,
It's a couple hundred light years away, probably. Cygnus X1, probably the closest one.
Hundreds of light years, so it's 100 of years. So if we sent a nanoprobe, using lasers and light sails and accelerate, I think that we can theoretically they should go at about 20% of light speed, but let's assume full 99% of light speed. So let's just assume light speed. So let's say it's 100. So in 100 years, it's going to get there and send us data.
So the problem is, in order to observe Hawking radiation, you'd probably need a fairly large experiment with high sensitivity. You have to sit around there for a while. So stopping will be the hard part.
Yeah.
I don't know if I care so much about Hawking radiation.
Most people don't.
Right.
I don't really care very much either, but this guy Sean had very strong opinions on it.
Why? Well,
I don't know. I don't understand, but he was arguing very, very forcefully that it is just. I think it's this though. So it's just Steelman his position. It's just like a lot of things in modern cosmology are so intuitive; they seem like fantasy. And so,
Like what? Like that? Like
well, like a lot of things, like black holes, pulsars, neutron stars.
wait. So hold on. So black holes. I can prove a black hole directly from Galileo. I don't even need Newton for a black hole.
Well, sure, but like the thing I'm saying is that people don't really understand like the intersection between like they think about these things as being just like fantasies that we can't observe or understand, and that's not accurate, but that is the impression that people have. There's a guy at Earth Awakenings called
But you know, I agree with them. So, like, I disagree with a lot of scientists, including maybe even Einstein and Feynman, about the very definition of science. And I can agree with where the flat earthers, you know, all the nonconformists, I can agree with at least where they're coming from, the notion that there's something wrong with science, with big science, with big physics. I can understand where they're coming from.
I agree as well, and that's what I was trying to tell Sean is like I just think that like there's a certain level of arrogance to say that we for sure know something about these cosmological things, right? Like I think that it would go both ways. I think that part of the
But that's not even what I'm saying. I mean, you know, you can have certainty or lack of certainty, but today's science is unintuitive, and I don't like that. Science should not be. That's not science. If it's unintuitive, it's no longer science. If your science is quote weird unquote, that's not science. That's religion. That's a mythology. That's like that is the opposite.
That's what Sean was saying.
Right. So science needs to. My definition of science is it must be mechanical. This universe must be mechanical. If your understanding of the universe is not mechanical, then you're a spiritualist. That's not science. Unfortunately, I think Einstein's special relativity and his rejection of the ether took science off course, and today we're paying the price because today's science is completely off the rails. It's completely out of control. It's not science.
Well, that's what Sean would say. You should talk to Sean, man. Like he was. I think he would have a lot of things to talk about because he kind of would. I think identify with what you're saying.
Right, but the
from
beauty.
My perspective.
Mm-hmm.
From my perspective, I'm a pragmatist, but you're correct in the sense that there was a transition from the classical era of physics in the late 19th century to the era of what we call modern physics in the 20th century, where our ability to even observe like we can't even really observe phenomena prior to making a theoretical statement in a lot of like, you know, modern physics. Like we didn't observe quantum mechanics before we came up with a theory of quantum mechanics, really. Is my understanding.
I disagree with that vehemently with everything you just said.
Okay.
So, I mean, science has to be obviously based on experiments, has to be based on experience, and has to come up with a mechanical explanation of observed phenomena and come up with predictions based on this simple mechanical theory. That is science. Now, whenever I study modern physics, I'm always looking for the experiment on which any modern physics is based on. So everything, as far as I'm concerned, everything is based on some experiment. And a lot of them, these are experiments that we can conduct at home.
Right. Oh, hey, Sean, how's it going?
What up, sir?
Hey, Sean.
Were your ears ringing?
Yes, sir. So we were just talking to Mr. Slave. I think he has a similar perspective to you on some of the issues we were talking about.
Right, but I
Slave,
agree.
you mind just
But I agree with everything that modern science says. I agree with special relativity, general relativity, quantum mechanics, black holes, like the expansion of the universe. Whatever modern science says, I agree with, except for I disagree with them on the definition of science. I agree with I disagree on interpretations. All my interpretations are mechanical. For me, the Schrodinger's equation describes a wave. It's a wave function that describes how the electron waves around the nucleus. I don't need to take the square to get a prediction where I'm going to find the electron, because the electron is not a particle. The electron is a wave. That is what de Broglie said. That is what Schrodinger said, Heisenberg. Everybody said it's a wave. So I don't need to look for a particle called the electron. That's nonsense. Anyway, Sean, what say you?
I agree with your your perception of how it works. I disagree with the beginning of what you say. I don't disagree with the definition of science at all. It's very basic.
Mm-hmm.
Very basic.
What do you
The inquiry of knowledge. That's all it is. That's all science is.
I'm a little bit more specific. I'm mechanical. Like my electron is mechanical. The electron is a wave.
Yeah, then we differ in that area.
My electron is a wave in the ether. So my base of reality is the fluid of the ether. And
You said he had the same ideas as I did. What kind? I don't believe in ether.
Well, in that he had some criticisms of the way that modern physics presents things, but maybe I misunderstood. Because what we were talking about last night ad infinitum was things that cannot be a priori observed. Are they scientific or not, or are they just mathematics?
No, it was literally it's kind of his argument. It's what can we do? What can we show?
Yeah.
What can be verified? That was the situation. Anything beyond being able to be verified or observed is in the sake of the debate, faith. It's faith.
Right. That's what your position was. Yeah.
Yeah.
I don't have a problem with faith.
And for clarification, not spiritual faith.
Right. Right. That was the sticking point that we should have gotten past earlier. So I apologize for that.
I mean, I don't have a problem.
I'm fine, honestly. Oh, sorry. Go ahead. Slade.
Yeah, I don't have a problem with the word faith. Faith, belief. Like, if I'm confident of a scientific theory, then I have faith in that theory. It's fine to have faith. I don't have faith in a person. Maybe I do. Like, if I feel that somebody is a great mathematician, if he says something, maybe I could have faith in, even if I don't understand what he's saying, that I would say my prediction is he's probably correct. I don't know.
But correct me if I'm wrong, though, Sean. When you talk about having faith, it seems to me that there is some belief that relativity should have been scrapped for a different theory.
No, absolutely not. What? Hell no.
Well, then
talking about,
why? Well, because we talked about dark matter as a correction
Placeholder.
for sure, whatever. For
No, because that's a big there's a distinguishing difference between a correction and a placeholder. A correction is found out it was wrong and we fixed it. A placeholder is let's see if this works to keep the calculations correct.
okay. So, what are the implications of something being faith? In other words, what
You not being able to do it yourself. Your verification for yourself.
Yeah.
Okay, so
Yeah.
I don't think
Then-
that's a meaningful distinction. Though.
Then I think
You will
probably
never-
everything
okay,
in your
you
life is
will-
going to be faith.
Yes, most of the stuff in your life. Yes, absolutely. Absolutely.
And that kind of means faith is a meaningless term.
No, I
No,
agree.
but why would it be a meaningless term? It's the distinction between things you can verify and things you have confidence in. What are you talking about? Everyone does it.
Yeah,
Okay, I guess then use
think-
a different word.
I think
No,
right.
just
I,
the word faith. Just look
I
at the
think-
definition. Simple definition for it.
right. I think there's too much faith in the experts in our society. We shouldn't have so much faith.
Mhm.
We should reduce the
Yes,
faith.
and what happens is then arguments are driven based on you not thinking it's faith, and it comes out as fact. And a lot of these things are not fact.
Right.
So what does it? What I mean, once again, so that's a ramification. What, or that points to a ramification. What ramification?
Be more specific. I don't understand what you're asking me right now.
Okay, I think that when you say stuff is presented as fact when it is not fact,
Mhm.
that is pointing to some sort of problem with the way that physics is
Nope, no
discussed.
problem. Didn't say there was a problem. I'm not denying
Okay.
science.
Well, okay. So then what are the ramifications of something being presented as fact, in your opinion, when it is not fact?
Okay. Do you believe Hawkins radiation? I love that. I'm going to say this. Do you believe Hawkins radiation is real?
I don't know. No, I have
Is
no
it part
idea.
of? Is it part of? Is it part of science?
Yeah, I guess it is.
Do you have- Do you feel that Hawkins is correct in his mathematical analysis of it?
Hawking.
Hawkins,
know.
sorry.
I don't know.
Most people, for the most part, forget you and me. For the most part, science in general has confidence that his calculations are correct.
Wait.
That is
What's
faith.
okay? So what's your opinion?
well, so what are the ramifications of this?
Why do you keep
I-
saying that?
Yeah,
Because
very simply.
I think you're smuggling in ramifications.
Okay.
And that you don't
Just so
want
you
to-
understand,
that you don't want
Omni,
to admit to.
Okay, yeah, Omni. I want you to understand something. This is not a gotcha. I am not trying to say anything is wrong. So stop talking to me that way.
Wait, Sean.
Well-
What's your opinion about Hawking radiation?
That it's not something that can be verified. It's not something that can be tested. It's not an observable phenomena. To me, it is something that is placed in to extend an explanation. It's all. It's literally just placed.
Wait a
in
minute.
To,
Hold
to
on.
explain
Hold on.
more.
I don't think that's true because
It can be verified.
yeah, I mean you can create a tiny
How?
because you can
Oh, this
create
is what we were talking about last night.
Here.
Hang on. Bacon, please tell me, how do you verify Hawkins radiation?
here. I was just about to. So
By-
I mean you can create
by-
if you create a tiny black hole, it should explode.
no, not creating
No?
tiny black holes.
Should. It should is not a way of verifying. Go ahead, Bacon.
Wait, it's my
can-
prediction. It should explode.
When this guy
Okay,
shuts
can you make a
up,
black hole? Can you make a black hole?
Can I? Why not?
Yeah.
Why not?
Can you? Okay.
Why not?
Okay, show me a black hole. Show me someone making a black hole.
Give
and
me the
being able to test
budget.
Hawkins
black
radiation.
hole, I
Maybe-
wouldn't say that to people. on the
Jesus
internet.
Christ. It's
So-
ridiculous, man.
So
Calm down.
yeah, it's because the idea of falsifiable
Mm.
is not innately is based on the type of the claim, not necessarily the level of ability right this second to test the claim.
Okay, and
False.
until it's observed or able to be verified, it's established calculation based on faith.
And well, no, That,
Yes, it is.
It's a established calculation based
Again,
on the
no,
math.
okay.
Well-
Do I have to say this again? It is not spiritual faith that I am talking about.
I-
Just look
I-
at the colloquial term for
So-
faith. It is
So
exactly
then,
what it is.
So then you that's why you need to talk about what you think the ramifications of this are.
No. I think
Until you're
having
until
I'm
you're
the
willing.
a way of observing it. All the above. The
Hold on.
contradictions to how physics explains being able to verify that not even being possible.
Okay, hold on.
Is that better? Is that good enough?
Wait.
No,
Hold on.
not really.
So- okay, sorry.
I have questions about it.
Wait 1 second.
Okay.
So
Again, how do you falsify?
Wait.
This is a
Well,
main
hold
question.
on,
How do you
hold on a
falsify
second.
Hawkins radiation? And don't tell me you make a black hole in the lab. How do you
no,
falsify
I won't
it?
tell you. That's lunatic stuff. Yeah. So if you have Hawking radiation, then black holes are gonna lose mass over time, and smaller black holes do it quicker. Right. So you can observe smaller black holes and notice a decrease of mass over large periods of time. It's not something that could be done in one generation. But
Have we done it? Have we
no.
got that calculation?
the claim
Okay,
wasn't
perfect.
that
So it hasn't been done. Okay.
So
I agree.
wait,
That's
it's not-
what I-
Okay.
It's,
You guys-
it's
okay.
something that is doable.
it's doable.
What are you guys arguing with me for? It's
Because-
literally
because-
it's just the fact of the matter. You
So-
can't falsify it right now, right? You can maybe
Oh,
in the
right now?
like
I don't
Sea
know.
Lion Prime was saying,
No.
just like Sea Lion Prime was saying last night, maybe in 100 years, maybe in some time they'll be able to. I get that, fine. But as of right now, it is the calculations are taken under faith,
Okay.
the trust that the calculations are correct and that their hypothesis about how it will work is correct because it's not observable.
Okay.
That is a calculation based on faith.
We don't have a
Look at the
disagreement.
definition.
Fine. We don't have a disagreement on the facts. Maybe on the words, but not on the facts.
Okay,
Everybody
then what are we
agrees on the
talking about
facts.
then?
Because
Then what do you-
because when you say that it's based on faith, what is that in opposition to?
Okay,
It's
but
based on
I mean-
Everything. Okay, what you talking about it, the way you were talking about it, is you having faith in calculations. Nothing that is something that can be verified, observed, or falsified.
so
That
what,
means
what
that when
do
you discuss Hawkins radiation, you are talking about it with faith.
There we go. Okay, we're almost.
Can
we're,
I-
we're,
can
we're
I-
getting closer. Just a second, Bacon. So, when I say that there is a theory of Hawkins radiation out there,
There is no theory.
Hawking.
yeah,
There is not a theory.
Tutor is making the best contribution on this conversation.
Hey,
Yes,
this is very important that
massively
you
annoying when people keep mispronouncing his name. His name was Hawking.
Hawkins. Okay.
Oh, you
Omni,
haven't-
I want you. This is
you
something.
haven't-
This is something you need to understand. This is very important. It is not a theory. Go ahead.
well,
Well, it's a
okay,
hypothesis, I guess, if you want to.
yeah, it's a hypothesis.
It's not even a
Conjecture.
hypothesis. Yep,
It is. It is.
concept.
It definitely
it is literally
a
a concept. It's a concept.
It is definitely a hypothesis and conjectured effect.
Right. So when I talk about it, how would I talk about it in a way that was not faith?
At this moment, you
Yep.
currently couldn't.
So, what if I say I don't believe it exists? I don't believe
That's
it will
your
ever be
opinion.
discovered. Yeah, but is that
Okay.
is that faith?
What are you basing it on?
It sounds weird to me.
No. This isn't spiritual faith.
So, what is the alternative? So you're saying that there is no way to talk about the hypothesis of
No. Why do you
Hawking-
keep saying? I am not saying any of this is wrong. I'm not saying any of it is fake. I'm not saying any of it is impossible to prove. I'm saying currently the understanding about Hawking. Did I do it
Hawking?
right?
Yep.
Hawking is unverifiable. It's unfalsifiable. It
Okay,
is
can
based on the trust
Got it.
that his calculations and his hypothesis on it will be correct.
Got
It is
it.
based on faith.
Got it.
Not
Omni,
spiritual.
Omni,
Let
hold
me
on.
try now.
No, let
I'm
me,
on
let
the
me. Omni, there is no disagreement on the facts between you and Sean. We're wasting time. You're
Well,
agreeing on the fact.
He's
look,
caught up on me saying faith.
Fine. Look,
Uh,
there's some.
And me too. Can I respond to that?
Okay.
Like, I don't care if we agree on the facts, we disagree on faith, and that's what I want to talk about.
What's the definition of faith, Bacon?
Well, faith would be when you believe something with unreasonable evidence.
Nope.
So, for example, if
Again,
your level
that
of
is
trust,
not the definition of
Just-
faith.
just-
You want to know
well,
the
as
definition
I
of faith?
understand,
Complete trust or confidence in someone or something.
Okay. We
well,
do not have
isn't
that.
faith? Yeah,
we
well,
don't have
we
that
don't,
with
yeah, we
Hawking
don't have
Hawking
complete
radiation.
trust.
It is
Why?
a
We don't-
conjectured,
okay.
tentatively
Okay, so
accepted effect.
you don't have confidence that Hawking.
Not complete.
No, definitely not
Oh,
complete.
okay.
Could be
It doesn't
wrong.
need it. Does, again, let me read this again. You guys aren't listening. Complete trust, keyword,
Stop.
or confidence in someone or something. It is not.
That-
It does not
That's
say
too
complete.
vague.
It does not
That's
say.
gonna apply
It does not say.
Oh.
It does not say complete trust
understand
and confidence.
Sure.
Okay.
In
We
that case,
understand.
you're using.
You're using a very vague definition to basically apply to everything.
Really?
Everybody
This
gets.
is okay.
Yeah,
so the
that is-
Oxford
hang on.
Oxford language is okay. Perfect.
Yes,
okay,
it's
well, guess what?
it's that's
perfect.
Here's the
Now that
reason,
you know,
Sean.
now that you know my definition of faith, am I incorrect?
Yeah,
Um,
you're
it's-
picking the most vague definition of it. That
I
It's
think
the number
word
one. What are you
is-
talking about? I
Sean,
typed
Sean.
in faith, and it's
Can,
the
can,
very
I,
first
can, can
definition.
we go
It's
one
not
at a
vague.
time?
What are you
Can we
talking
go one at a
about?
time? Can we go one at a time?
Yeah,
Okay.
go. Yeah.
Right. So words have multiple ways they can be used. The dictionaries are going
Yep,
to give you
and-
all of the ways they can be. Oh my gosh, Sean, let me hang on. Oh, we don't need to mute Sean.
I just wanted to go one at a
Listen to this,
time.
man. No, hang on. I want to make this very clear because I did this with Omni. I had to do this with Sea Lion last night. This is not spiritual faith. The definition you gave was for spiritual faith, and I've said this numerous times. It is not spiritual faith.
Yeah.
So do not
but
come at me
when you
like
say-
I'm implying. Don't come at me like I'm implying it is.
I know you're not. But if in the middle of a conversation you say, okay, you believe that on faith, what everybody's gonna hear is you don't have evidence for it. You don't have a good reason to believe that. And if you
Good
say
thing,
it,
at the
that's-
beginning of
that's
this
what gets understood. That's the definition that everybody's gonna take if you say that in the middle of a conversation. That they have no reason. Oh, definitely.
Yeah, that's
Good
sophism.
thing at the very beginning. Hey, good thing at the beginning of the conversation, I did clarify it. I'm sorry if you weren't listening to what I was saying. I
Yeah,
did.
but that's a bit of a useless.
Omni
It's like
the
I'm going
first
to
thing,
define.
the first thing Omni did was assume that it was a spiritual faith. In the first three sentences of this
Yeah.
conversation, I made it clear it wasn't spiritual faith.
Not true.
So if you go and
Yeah,
look it
but
up
that's the same
and you
thing.
tell me that no, it's not. No, it's not.
Wait a second. I'm gonna say. I was gonna say that's the same thing as, and I was gonna say something else. You don't even know the rest of the sentence. So that's the same thing as saying I'm gonna define this insult as a nice thing, and then I'm gonna use it for the rest of the conversation. I don't do that.
I
I
clarified
hope you-
my definition of faith. The definition of faith, and here's the thing: the definition I just read literally is what I've been talking about this whole time and clarified. Whether you heard that definition or not, or give a fuck that I said it, that isn't on me. That's a you problem.
No, because that definition doesn't apply to how you talk about a theory.
Yeah, it's not a theory. Oh God, Jesus Christ! Just so you understand something.
I don't know what to do. There's like no response. They seem to have a channel.
Hey everyone, thanks for tuning in here. Give us just a moment. I am muted in the Discord chat. I apologize.
Our ways. That's a brilliant move. It's like, okay, cool, Chief, cool story, right?
Here.
And then there's university records for all over the universe. Got to put those in there. And then there's the news headlines for the.
Yay.
The trick is it's time squared plus velocity times time, right? And then you break it down. It really just means to solve for little a, the acceleration towards the Earth, so to speak, or I don't know what Dell would call that, the inverse, right? He says this doesn't exist, but the little a equals 2 times the height over the time squared. So to do an example of that, right? You can just put it in a real life situation and say that if you drop a ball at this height, right, it takes 1.43 seconds. You drop it from 10 meters. Quickly do some math. 2 times 10 over 1.43 squared. And 1.43 squared is 2.049. 20 divided by 2, 9.78. Pretty on the nose, right? So this is important because they use that for calculate there. It's a direct inference. It represents the metric per square. They infer the torque between the mass. So the other thing they do, those rules, to replace it with the weight, right? So distance between the centers of the masses, and the typical of the experiment, it's like those 2 lead balls, right? And then T is the torque between them. The measure looking downward, it's like stereographically looking down on the instrument. It'd be like the angle with which the thread is twisting, right? The amount that the ball tracks to the other ball as measured in twist. Essentially, yeah. Since you have this, T equals.
I don't know what's going on here. But there's no one here. It's an empty server. It's a dead server.
So that is what the faith here means. But when you then say you guys have faith in, that is surreptitiously switching around the definition for the religious one, in that you have no reason or argument for believing something. You have no reason, either evidence or logic, to believe in something. That is the religious definition. What you've done is you've surreptitiously switched the definition there for one which is much stronger and which we do not hold.
Okay, well, that was the fucking definition. Okay, so you understand, I don't play games and I don't play tactics. So that I typed in faith, and that was the definition that came up. I didn't switch. I didn't try to play games. So the fact that you think I did is why you probably aren't getting anywhere in this conversation, because you think I'm playing a game.
Well, that is he's calling out exactly what it seems.
Yeah,
to me like.
you call out something someone is doing, and I am not doing what he is saying, and I haven't done that. So exactly what I was saying when I was interrupting before is, don't try to tell me my position if it's your interpretation of it, because it's not correct.
Hey.
What's up, man?
No, what's up?
That got pretty heated over there.
Yeah, but it's a semantics. That's the worst type of discussion.
I know. That's what the debate was for like 3 hours last night.
That's not good.
No, it was. I was trying to like build bridges with Sean, because Sean is like skeptical of a lot of like modern cosmology, and but
I did not understand that he has any disagreement with modern physics, with mainstream science. I made the claim that it's a semantic disagreement. He didn't say that he disagrees with anyone on anything. You're submissive. Honey bunny.
Yeah,
Oh.
this is my attack furry. I unleash this attack furry on other servers when they disappoint me.
Wait, it's you?
No, it's not me, but they have a tendency to send people furry porn in DMs. So.
I mean, it says that it's a feminine femboy.
Yeah.
But they're not listening and they're not talking.
Yeah, I don't know what they're doing.
Anyway, can you drag anybody in here so we can have a discussion? Like I
don't know. I want to see if anyone wants to join. Let me see.
I worked on my paper today. I have like nine figures that I created.
Oh, cool.
Let me share it. Let me share it.
I think Omnivore would probably rather be in here, but he's.
Hey.
Hey, Lori, what's up?
Yo.
Hey. So, oh, it says Ricky? You called him Lori?
Yeah. We had a joke the other day where everyone changed it to Rick because there was 2 Ricks in the voice chat.
Okay.
And so like 12 of us posted, changed our name to some variation on Rick. It was kind of a silly joke.
Wait, Sea Lion, do you smoke?
No.
But you have a little bit of breathing, right? A little bit of a breathing issue?
Yeah, I think I
might
be getting a little sick.
You're not overweight?
I'm a little overweight.
Do you exercise?
I have, since I've been on Discord more, I haven't been exercising enough, but generally I do exercise, yeah.
Like I feel like you're half choking, like you're not getting enough air.
Yeah, well, I do have apnea, so.
Oh, you have apnea? Okay.
Yeah.
Did you try singing?
No. Is that supposed to help?
It did. It helped me. I used to have issues, and when I used to have like a apnea or asthma attack, like I found out that singing helps. The vibrations of just the vibrate, or just talking or yelling or humming, like by just vibrating your system, just causing this vibration, it clears up the passages, like the air passages. It relaxes. You can try it. You tell me if it works. Like anytime you're talking, right, you're causing a vibration. So
gotcha.
Yeah, I don't know if it will work. Anyway, so he came and he went.
Yeah. I guess he wanted to hear people scream at each other over semantics.
So
Sean gets pretty heated.
I see. So, but he doesn't want to talk to me about my paper.
I guess not.
Anyway,
if you want to set up maybe an event, we could see if people are interested. There's somebody on the server who has a degree in relativity, actually. We could do like an event and like stream it out if you want to like present your ideas in a more formal setting, perhaps. I don't know if that's something you'd be interested in.
I don't like formal settings because it's too much pressure on me. I'd rather just spontaneously present a paper.
Yeah, I hear you.
Anyway, do you want to take a look at it? It's just
I have it. I have it open. I'm taking a look. I see your ether flow stuff.
So it's basically everything. Oh, there's a bunch of people looking. anonymous hamster and anonymous camel, and there's already a comment. That's good.
Yeah, no, people on the server are cool and interesting, and they generally are pretty open to new ideas as long as you're open to. I mean, we deal with Sean, and Sean will not be so open to new ideas. There's another server. Let me send you the link to it. The Earth, so the Aether Cosmology one.
Yeah,
they're pretty touchy over there. But there's this other server.
I already went to the Aether Cosmology. There's no one there. It's a dead server.
Yeah.
Oh, there's one
Yeah, it's
person.
pretty dead. But here, let me post this one as well. I'll DM it to you, but
okay.
I'm timed out for trolling, but this is overall a pretty good server to talk about things like this. Although they're mostly flat earthers, but they can be pretty interesting to talk to about some of these ideas. So
let me try and join. Introduction. I hate joining new servers. It disconnected me.
Before Christ.
I don't know about the Hebrew. I just know that the word Christos was a drug term, pharmaceutical term in many Greek.
It's good. I was able to join. Anyway, so what do you are you following the diagrams? Do you understand the diagrams?
Yeah. I think I see what you're saying. I think it makes sense. I think the next step here would be to start shaking out some of the maths. Like, are you still planning on? Are you going to develop this as a metric in the Einstein field equations, or how do you what framework do you anticipate this will be?
This is
modeled in.
This comes out directly out of Newton's, gravity, which is just Einstein's gravity. I mean, I don't need GR. GR is relativistic. I don't need to discuss the relativistic effects. This is what Newton's. This is what Tycho Brahe said. Tycho Brahe. It's not even Tycho Brahe. It's like, because we see an apple fall and there's no strings attached, this is the only explanation I have to that. Replace G with C. Who's Lucas?
There's a typo. There was a typo in.
Okay.
It was Tigo.
Okay.
That's a small thing.
Amazing. So I mean, this is an intuitive explanation of gravity, and I mean, everybody agrees that a black hole is black, and this is even from experiments. We know that a black hole is black, and also we know that light bends. We know from experiments that light bends. So the simplest explanation is that there is a fluid that flows. That's the simplest explanation that I can give to gravity. And simultaneously, did you get to the last to figure 9?
Yeah.
So what do you understand?
Yeah, I took a look at all of them.
So what do you understand from figure 9?
It seems like you're developing this idea of aether pressure and low and high pressure creating flow. All that makes sense. I would want to now start working through some of that fluid mechanics, or like whatever framework you're going to use to conceptualize and make predictions off of. That's
already
probably the next step here.
Oh, so you want? So I have another paper. The correction to Michelson and Morley.
Oh, cool.
Yeah, that's the next step. Is this? Yeah, the live stream. So, but I don't have any diagrams for that, but I can put together a bunch of diagrams very quickly, because diagrams are easier for me to produce and easier for people to understand rather than Writing is impossible. Writing, I'd rather kill myself than write. I wish I could give ChatGPT the diagrams and ask it to write the paper. I'll just do the diagrams. I'll come up with the theory, and ChatGPT will just write the paper. Do you know what? You want to give me a couple of minutes? I'll put together a bunch of diagrams, and you'll give me feedback.
Oh yeah, take your time, man. Yeah.
Okay. Are you getting started with your PhD?
I got to get back on track with that.
Do you need me to motivate you to get your PhD done?
Yes, I need people to motivate me, man. I've been debating people online too much and not spending time working on it.
Wait,
so.
Then just tell me your thesis. That's probably the easiest way to motivate someone is just argue over the thesis.
Yeah, so basically my thesis is on spatiotemporal forecasting. So if you're trying to forecast like wildfire risk or temperature over a large area of both space and time, I'm developing algorithms that allow you to do that on a laptop instead of like a supercomputer.
So how are you making it more efficient? What's your algorithm, or is it secret?
It's based on it's not secret per se. It's based on pretty simple principles of autoregression, and basically I use a Kronecker decomposition of the space-time covariance matrix.
Why are you using You're using Minkowski space-time?
No, this is purely a statistical model.
So why do you call it space-time?
Because there's space coordinates and time coordinates,
okay.
and that defines a spatiotemporal random field.
Okay, so so your thesis, like no one has done this. This is like your venture.
I'm making a novel contribution. Yeah, my contribution is creating a particular structured covariance model for this particular class of modeling. I've done a proof of a derivation of this model, showing that it has a particular property which makes it very computationally efficient. And now I'm working on computational studies to show its efficiency.
Okay, I have no idea what you're saying, so I cannot debate you whether I can't even tell you if you're right or wrong. Can you simplify it to so that I can understand what you're saying? Like,
yeah. So basically, are you familiar with the idea of a covariance matrix?
No, that's where I stopped my GR, exactly at the covariance step.
So all it really basically is like a spatial covariance. If you have 100 locations in space, sorry, people are just like getting pissed off at this furry. Nobody wants a furry on the server. So, gosh, I'm sorry. I'm sleep deprived, so it's a little hard for me to explain this right now.
Forget it. You know what? Let me. Okay, I'm just trying to motivate you to do your PhD, but let me. So, did you go over all my figures?
The ones that you said, yeah. I'm looking at the figure 9 right now.
So, what do you think of what? Yeah. So, what do you think of figure 9? So, can you explain?
It makes sense. All of this makes sense intuitively.
Can you explain?
I just would want to.
No. Can you explain to me the life cycle of the ether according to my model?
Well, I think the ether is. I'm not sure where it's being created. Is there a creation zone or?
Yeah. No, there's no zone. It's dark energy. It gets spontaneously created in figure 7.
Yeah, I see that. So, I guess what I'm not. Yeah, so it's created it just everywhere in space constantly, and that's creating like ether pressure.
Exactly.
And areas of lower and higher pressure.
Well, low pressure. That's figure 8. Figure 8 and 9 is the low pressure. and that's the completion
Yeah.
of the cycle.
That makes sense.
Now, this interaction, this annihilation, that is the Higgs mechanism. So this is when the ether endows mass onto the electron. This is also figure 8 and 9 is quantum gravity. So I get quantum gravity out of my ether theory. I easily explain quantum gravity, the gravity at the quantum scale. Yeah, it's a very efficient theory. I don't understand why. I mean, that's like,
no, I have no issues with this. I just think that we should just do some work and put something together and get it at least put on archive. You know.
right. I need people to challenge it, because this is just, if you go to the beginning, the calculation, I just started putting together the calculation, but it's just F equals ma and F equals gmm over r squared. That's it. I mean, that's all it is. From that, you can see that there is an acceleration vector field, and then there is a velocity vector field, and that's it. I don't know what else to say.
Yeah, no, I think just, sketching this out, and just feel like I'm good at writing, so I wouldn't mind helping you to, write out some of the details to like flesh out the figures with that.
Mm-hmm. Okay, I'll put your name on it.
Cool.
I mean, I have many.
Good idea. I like it.
Yeah, I have many papers that are all in the vicinity of this ether. I want to have a paper on black holes, on the internal quantum gravity of the black hole. My black hole, it's basically just a neutron star. Internally, a black hole is still a neutron star.
Gotcha.
I think. There's nothing. There's no other universe. There's no wormhole. There's no white hole. None of that. So, like, I'm very mechanical. My universe is very mechanical, and it's still just ether.
Yeah.
Internally, it's just ether. Anyway, I'm gonna. I'll make another paper. The diagrams of the detecting the ether, the fix to the Michelson-Morley experiment. I'll show it to you. It's really interesting.
Yeah. Nice.
If you want to make a do you think people will come to the presentation?
Definitely, 100%. We'll probably have at least 10. We would probably have at least 10 people show up if we schedule something.
I see.
Maybe 20 people show up.
The problem is
very interesting.
How would I share my, I would share my screen?
Yeah, I mean, we could do it very informally. There doesn't need to be.
No. It's a technical problem because I'm streaming, and when I stream, I can't share my screen in Discord.
Oh,
that's the issue with Discord.
I see. Yeah, I'm not sure then. Some people have done that. We could ask. Do you have OBS?
No, I mean, I tried. I have it, but
I would set up OBS probably. That's probably the best way to do it.
Yeah. I actually set up OBS, and it connected correctly into the wrong account, and I couldn't unplug it from the wrong account to the correct account. Anyway, I'll struggle with it. Anyway, I'll prepare another paper, a bunch of diagrams, and we'll move on from there.
Cool, man.
Because that would be very good for me. And you can, I don't know how to help you with your thesis because it's way over my head. I have no idea what you're saying.
Maybe just having someone that is telling me to stop wasting time arguing with flat earthers.
I could definitely tell you that. I mean, you saw how quickly I left that non-debate. I could tell right away. It's a semantic discussion. It's a complete waste of time. Everyone agrees on the facts. Like that's the
Great.
first thing I look for. Is anyone disagreeing on the facts? No, everybody's agreeing on the facts. Okay, it's a semantic discussion. We're wasting time.
Yeah, that's a good point.
Yeah.
Yeah, I should do that that's a good criteria, because it's just like otherwise it's just like jerking yourself off like
Right.
mentally, right?
The question should be: are we disagreeing on the science? Do we have a scientific disagreement? Are we disagreeing on the science? That's the question. There's no scientific disagreement. So done. Anyway, I'm gonna go back to my server and I'll prepare a bunch of slides and I'll update you.
All right, sounds good.
All right, I'll see you later.
See ya.
All right,
Thanks.
bye. Thanks, bye. Wow, he is amazing. That's an amazing guy. Wait, there's one more. There's a mention. But how can I find the mention? It's like I never know how to find the mention. I always have to look for it. Slowly look for it. New message, but it's not a mention. The irony. Okay. Okay, so we prepared the slides. These slides are so easy to prepare, and once we have the slides, yeah, but I should do the math. He's right. I should, wait, this is the one. I should add more math than just this. There's a bunch of math I need to do. But he's right that we want to be able to prove who's Anonymous Hamster? Where? G with C, did I replace it? Okay, so this is figure 2, figure 3, figure 4 is the galaxy, figure 5 is the universe. Okay, let's do the diagrams for this paper. So this paper is based on the paper we just explained. So we just explained how the ether works. The next step is to, let's prove it. What's this? So let's now so let's prove it. So what was the final? Okay. So we're going to use so I'm assuming yeah, we need to show the calculation. Okay, we're not going to do this because this is okay. We need to show the calculation. Yeah, we need to show the calculation. The diagrams for the calculation. So we're going to start from the Earth. So the Earth is green. Is this green? Green. Okay, this is the Earth. And now we're going to have, let's just use 4 arrows. So we're going to have 4 arrows. They're going to be blue. Let's use this blue. Blue. All right. Let's put this in the center. We're going to have ether flowing into the Earth. Okay, so this is one here. And one here. Centered. One here. Okay, this is the ether flowing into the Earth. That's a given. And the next step would be to notice, the only way we can notice the ether is at the equator. Well, we can do the calculation at the equator and we can show that at the equator we should be experiencing an ether rain, but not at the North and the South Pole. Okay, so we have ether. Let's have some call outs. So this is going to be transparent and it's going to be pinkish. So this is going to be the ether flow. Well, that's second. The first thing is the Earth. Okay. This is the Earth. This is the ether flowing into the Earth. So it doesn't matter whatever you touch, it grows and loses. This is terrible. Oh, but this way it's better. Okay. Anyway. Okay, 1 second. A little bit bigger, like this. Okay. Okay. This is the ether flowing into the Earth. This is the Earth, but this is incorrect. Like this. Okay. So this is the Earth. This is the ether flowing into the Earth. And this is going to be figure 1. Let's have a shape at the bottom. Maybe we'll have it at the top. It's going to be transparent. So this is figure 1. But it's going to be like this, and like this, and like this. Yeah, we have to have an enclosing, something enclosing it. Otherwise, it's going to be very difficult to understand. Why is it so tiny? That's not the reason. Really strange. Let's add a shape. Yeah, it's gonna be just a shape. And order back and make it transparent, but give it a pinkish background, something like this. And this can also be pinkish. Let's see this. Why is it so tiny? What's going on? Why is it so tiny? Wait, can I make it bigger? Really? I can control the size? But where is... Why is it on the left? What is going on? This is so strange. Why is it missing the left side? Forget it. Let's just create a new... Insert a drawing. Let's go here, take all of this, copy this. Let's try this again. Insert drawing. Paste, save. No, it's exactly the same. I don't get it. I don't know. Let's look at this paper. This paper is perfect. It's the first one. Let's just copy this image and bring it over to here. Okay, perfect. Now let's take this image, take all this, and bring it over to this guy. I don't know, will it be destroyed? Yeah, it gets destroyed. So something is ruining it. Maybe this thing? That was the problem. Okay. So we can get rid of the others. Okay. So figure 1. This is the Earth. This is the ether flowing into the Earth. Okay. Figure 2 is going to be, let's look at the northern hemisphere, and let's look at the northern hemisphere. This is going to be very difficult. How are we going to look at the northern hemisphere? But what do I want to say? I want to say that, well, we need to show that it's a hemisphere. So we actually need a curve, but it needs to be a semicircle of sort, like an arc. Is this an arc? So basically from here to here. What the heck is that? What is going on here? What? What? Let's do this again. So let's insert an arc. Oh, okay. So that's what it looks like. So we need the arc to be like this. No. This is the arc. It's never gonna fit. It's never gonna fit. If this is the size of the arc, 135. What about this? No, impossible. Oh, look, it's almost there. Almost there. Oh, can't really. Anyway, you have to make this sphere smaller. Oh my god. Oh, come on. Make it smaller. Let's center it. Something like this. Okay, now let's take the arc. Bring it to here and to here. What's this? Oh my god, because of that? Yeah, it's very difficult. Yeah, it's very difficult. It's not so clear what I want. Forget it. I'm not gonna do the arc. It's impossible. Let's just take the sphere. Let's just say this is the North Pole. And let's suggest that it's rotating. Do we have a rotation arrow? Sort of. This is sort of a rotation. So, yeah, that's pretty much it. Where it's basically like this. So this is east, this is west, this is north. This is the right-hand rule. So the sun rises in the east. Let's have some call-outs. Okay. 1. This is, well, this is Earth. This is the east. let's go to the other side. This is the east, west, south, north, and south. This is the South Pole. Oh, I'm not sharing. Oh, I love it when it happens. I don't share. Is anybody watching? No one watching. Am I inside? So what was I sharing until now? He creates new ether. Okay, I was sharing the wrong paper. Look, we're up to 183 subscribers. That's amazing. Okay, so this is what we're drawing. So 4, this is the South Pole. And the North Pole. Come on. Fine. Oops. The North Pole. So this is not east, this is eastward. Is there such a word? Eastward? Eastward. Westward. And this is the rotation, the direction of the rotation of the Earth. So the sun rises in the east. Direction of the rotation of the Earth. This is getting in the way. So we can move this to the other side, to here. Okay, this is the direction of the rotation of the Earth, so that the sun rises in the east. Okay. This is figure 2. Figure 3 is back to the ether. Okay, so back to the ether. Yeah, we basically only want the northern hemisphere. So back to the ether. So okay, let's add ether lines. Let's go take an ether line from here. So this is an ether line. And let's have another one over here. Is this the... Yeah. The point is that a person standing here, the ether falls directly on their head. The person standing here, the ether is slanted, is falling down slanted. So let's add a person. That's going to be difficult. How do you add a person? Here's a person. So person, people are shades of brown. We'll make them beige. Here's a person. So there's a person here. Let's make the earth a little bit smaller. Let's make this arrow a little bit smaller. So there's a person standing here. Oh, the earth is no longer at the right spot. Okay, this has to be center. This has to be center. This has to be center. We need another person. There's going to be person 1 and person 2. This is person 1, person 2. Person 1 at the North Pole, person 2 at the equator. Okay, back to callouts. Let's take a callout from here. So this is going to be person 1. And he is at the North Pole. And now we'll have person 2. This is going to be person 2. He is at the equator. He is at the equator. At the equator. So person 1 has, is this figure 3? Figure 1, 3. Did I just destroy figure 2? Amazing. I didn't copy paste. Is there a history? Where's the history? Where's the hysterectomy? This. This document is ready for offline use. But where's the history? Version. So 1, 3. It didn't save. We didn't save 2. Okay. So 2 was. I don't know if I can. Let's try. Forget about the history is not going to help us. We have to start naming versions. Okay. There's no undo. So we can take 3 and copy it and put it somewhere. Like let's create a new, I think I have a new dumping ground. Okay. So I put it somewhere safe. Now let's try to undo this. So, oh, this is 2. This was the end of 2 because if I redo, then this is it. Then this is 2. Okay. So this is 2, and now we're gonna go. Now we actually have 3. This is 3. Saved. Wow. Okay. So this is 2. We should call this person A. And this is person B. This is person B. Okay. Now, what does person A experience? What does person B experience as far as the ether falling on their head? Okay, so let's copy, paste. So this is going to be 4. So no more Earth. So let's talk about person A. Person A experiences, let's add the ground. So it's just a line. We have a line. Let's take the line from this paper. We have a line, like the ground. And this, 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 and this. Copy. Paste. Okay. This is our person standing on the ground, experiencing the ether falling directly on their head. So person A at the North Pole is experiencing the ether falling directly on their heads, directly vertical, falling perfectly vertically, Is experiencing the ether falling perfectly vertically towards. Perfectly vertically. That's it. There's nothing else. Just let's make a note that this is the ground. People might not know that this is the way we denote the ground. And we need to say that this is person A. And this is the North Pole. So, 1, this is the ground. 2, this is person A. The North Pole. And person A at the North Pole is experiencing the ether falling perfectly vertically. Yes. This is 4. 5 is person B at the equator. This is person B at the equator. And here is, well, it depends on what are we looking at. So this is, where is east, where is west? So if on the right is the east, then it's no longer falling vertically. It's falling at an angle. There's a tiny angle that can be measured. So person B is experiencing the ether falling off vertically. We can calculate this angle. We don't care about the angle. We can calculate both speeds. We can count off vertically. There's 2 components. 1 second, there's somebody talking to me. No member lobby. Main chat. Hi. Hey.
Oh, what's up?
Hey, great. How are you?
I'm good. How are you?
Fantastic. Are you an ether theorist?
One second. Your mic's a little low.
My mic is low? Are you sure?
Yeah, or maybe you were like turned away from it a little bit. It's clearer now. What did you say?
I said, are you an ether theorist?
Oh, yes. Yep.
Hmm. How long have you been an ether theorist?
Ooh, about a year now.
Hmm. And like, are you doing any active research?
Yeah, as a matter of fact, I'm working on a presentation for next week titled "Introduction to Ether Physics," with a dynamic ether theory, where the ether theory, where the ether is like what does everything in ether in motion over a stationary Earth.
Mm-hmm. So your theory of ether, it includes what natural phenomenon do you account for using the theory of ether?
Well, it's the medium necessary for electromagnetic propagation, and from that, it serves as that background medium for electromagnetic propagation, and then all motion is relative to that, and that's measured through interferometry and other mechanisms like radio signals, so like GPS, stuff like that. All measure motion directly proportional. And then you have things like the Foucault pendulum, where the ether wind causes the retardation in that, in the pendulum swing, which produces that precession.
What do you mean? What precession?
So you know how a pendulum precesses into I forget the word for it. It makes like a spirograph. Is that the right word?
I don't know. I never heard of this. I mean, except for like I went once to a museum and they had a huge pendulum, and it went around in a circle because the Earth rotates, and it's like
That's what,
yeah.
Yeah. So that pattern it makes, if you plot that out, it makes like these circles or whatever, right?
Yeah.
And that pattern is due to what I would consider the ether wind. So if you scroll up in the main chat to 12:10 past the hour, I put a little short or a link to a short from Robert Bennett, who gives his thoughts on how and why a pendulum precesses.
But
they
we
say,
know.
Earth rotation.
What do you mean they say? That's the simplest explanation. No?
Sure.
So why do you need more than just the Earth rotation? I mean, the pendulum
Earth is stationary, so in order for me to rectify the pendulum, the ether has to serve as the mechanism for that. And there is a measurable velocity gradient from the surface of the Earth that when you go to higher in altitude, the velocity increases, and the velocities are pretty extreme, right? Starting at like 6 kilometers a second on the surface, and then at altitude you get up to like 12 kilometers a second at just 1,800 feet.
Wait,
so there's a velocity gradient.
In what direction?
West to east.
West to east?
Mm-hmm.
Why?
Well, the stars rotate, and there's a translation of motion that comes from that.
The stars rotate? So the Earth doesn't rotate?
Not in my model.
Oh, okay.
Yeah, in my conceptualization, because I'm not just like I don't just believe in the globe, right? Like I'm also a flat earther.
Oh,
either way you look at it,
nice.
But the rotating globe thing, right? That's just a coordinate system to me. I don't like this explanation applies to a globe as well. It's not mutually exclusive to a flat earth or anything like that. It's because basically the way it would work on a flat earth, right? You have an ether vortex emanating from the North Pole.
Why?
So what that'll create is is latitude dependent fluctuations in the speed of light. So when they
Wait.
talk about
Wait, I'm
ahead.
I'm a little bit lost. So what's causing your ether wind?
I have no idea. It just seems to be following toroidal geometry.
Toroidal? Why? Why would it follow any geometry? What is the yeah?
I don't know. It just does what it does. Why does the Earth rotate, right? Like on the inverse, why does the Earth rotate?
I mean, so my ether theory is very conformal to all of physics. I don't deny any conclusion of any physics. I just have a simpler physics. My physics is simpler, but it's still I end up with exactly what all of mainstream physics, what big physics says. I agree with everything big physics says, except for instead of a vacuum, I have an ether. And
yeah, same.
No, but my ether is also gravitational, and it's also quantum. So my ether starts at the quantum level, and it's gravitational. It's luminiferous. It is the medium for light, and it's also dark energy. It actually is the pressure that expands the universe. It's everything. It is the unified field theory. My ether is unified field. Is the unified field. It's everything. It's the Higgs field. It's quantum. It's the quantum field. It's gravitational field. It's dark energy. Basically, I can explain every physics phenomenon. I can account for all of them, black holes, everything through the ether, except for dark matter. I didn't figure out dark matter, not completely. I started working on that, but I have other things.
If you want a boost on dark matter, Bennett just gave a presentation. I'll link you the timestamp to it. But, he incorporates dark matter and dark energy in his cosmology conceptualization of what's going on in the cosmos. So yeah, you could definitely substitute in an ether mechanism for all of those things. I find explaining the movement of the cosmos unnecessary. Like in regards to how you said, your theory capitulates to the mainstream narratives, and like it definitely could, right? You could definitely use ether as a mechanism for expansion and gravitation, etc. But you don't have to, right? Because everything that moves in the sky is measured through the periodicity of its motion. Like, so basically how long it takes to complete a cycle. So they don't actually make any predictions on anything, and then through that periodicity they algebraically swap in the gravitational constants and mass so that they can derive what the mass would have to be, to produce that event, like they did for everything else. And then when those predictions failed, they were like, oh, you know what, dark energy, dark matter is there's some other thing out there that we can't see that's substituting enough gravity to hold everything together in the way that we need it to. And then for the expansion, et cetera, and all of that, it's all supplemented by other degrees of fictitious forces and causes to supplement the original claim that gravity and mass attracting mass is the reason why the heavenly bodies move. If you I'm perfectly comfortable with just using Kepler's laws for the periodicity of things, because that's ultimately what it is, which is just based off of empirical observation with no causal mechanism. I don't think anyone. Hold on 1 second. I don't think anyone knows why the bodies move.
What do you ask me? What do you mean you don't think anyone knows, etc.? Like, just ask me. What do you mean? Like, I can account for everything except for dark matter. Like, I can explain to you everything. It's not just me. I can use modern physics.
Yeah. So check it out. The causal mechanism, right, of the motion of the heavenly bodies, including us, they say, right, is big G, and the mass of the mass relationship between us and the sun. And then when you get into the heliocentric model, it would be the mass of the sun versus, everything else, right? You produce those effects. Well, if the Earth were moving as a causal mechanism from, mass attracting mass, it would have to be moving at a velocity of 30 kilometers a second. And every interferometer experiment ever conducted never gives a velocity of 30 kilometers a second.
Right.
So
I'm
so
actually
the Earth isn't moving.
I'm actually writing a paper right now fixing the Michelson-Morley experiment. I can explain why Michelson and Morley got a null result.
Oh, they didn't though.
What do you mean?
They measured 6 to 8, or they measured what was it, 6 kilometers a second, 6 to 8 kilometers a second. Have you heard of Dayton Miller?
I don't know. I don't recall. But wait, you're saying Michelson and Morley didn't get a null result? He got a Nobel Prize for a null result. Michelson.
Yeah, so that's a huge bait and switch / lie, mainstream lie. Let me pull up his page.
What do you mean? Michelson died thinking that his experiment, he couldn't figure out why it failed, but he got the Nobel Prize for the failure.
Yeah, so it didn't fail, right? He measured. Here's what happened, right?
Do you have the raw data from Michelson and Morley?
Yeah, I'm pulling it up right now.
Okay.
Can you see my screen share?
I'm watching. It's
so they did 6 days of measure. Oh, can you see that?
Yeah, I saw this. Yeah. Mm-hmm.
So they did 6 days of measurements.
Mm-hmm.
And they got 4 to 6 kilometers a second. Now their predicted value was 0.05 of a fringe. They were accurate enough down to measure 0.02 of a fringe. They measured what was it? 4 to 6 kilometers a second. And they go on to say, if the results are less than expected due to all the other solar motion and stuff, maybe we should do this. We should repeat this throughout the year, et cetera, et cetera.
So
and then he goes on to say that if you take these measurements as is in the first order, then you can't use Lorentz's theory of link contraction because it produced a value that exceeds link contraction, and you would measure it as a null in your frame. And then Stokes's theory about the stationary ether being carried in the opposite direction of motion for some unknown mechanism, which he used to explain Airy's failure. They say that doesn't apply here either because the fringe is too big for that.
What's a fringe?
And Michelson, the fringe displacement, so it's the gap in the wavelengths of light that they're measuring.
Mm-hmm. Okay. So what are we looking at? This sinusoidal two graphs. What are these? I mean, I saw them and I read the paper. I couldn't understand what he's referring to. What is that?
Yeah, so these are the minimum and maximum dimensions of the fluctuations of the speed of light that they measure. So when they plot this is what they expected to plot out the dotted line here, and that would have equated to 30 kilometers a second. What they measured was just over one fringe.
Mm-hmm.
So
they got one fringe? They got a whole wavelength?
They got just over a fringe.
And that equates to 6 kilometers a second?
Yes.
In what direction?
5 to 6 kilometers a second.
In what direction? Do you know?
This would have been west to east as well. So the orientation that they had it set, what they were doing is they had light at a right angle, to the north and west, and then they would just rotate it.
Mm-hmm.
And thus that, if you see these numbers here, it would use that to correspond to when they were, in alignment with the perceived direction of motion versus not. And that's how they were determining if, the causal mechanism of the fluctuation, right? Because if it's just doing it in every direction, then, they can't really discern anything from it.
Wait,
but when it's in certain alignment.
Hold on.
Go ahead.
I can barely follow what you're saying. So, but you're saying they got 6 kilometers per second? I'm trying to think. 6 kilometers per second. Because my calculations are much less.
Yeah. No, you see this derivation right here?
But let me
How
ask you.
it comes down to.
But wait,
Go
so
ahead.
they were rotating this over a period of a couple of seconds? How fast was it rotating? Like instantaneously? Like over a couple of seconds?
No. It was extremely slow. It took about 6 minutes to do a full rotation, and while it was rotating, they had a guy, walking with it. I'm assuming, or I don't know how he was moving. They might have been pulled on something, but basically, what he was doing was looking through this eyepiece right here, this telescope. Was looking at the canvas where the light was being projected. Then they had another guy that was lining up a crosswire over that to mark the spots. So then they would go back and measure the difference.
Okay, so 1 second. If they got 6 kilometers a second, if they got something to change, are you sure?
Oh, I'm 100% sure. And then this was repeated by Dayton Miller for 30 years because they actually never. But real quick before we move on to the subsequent measurements, this derivation here that they came up with, d2 or 2d times v squared over c squared, right, is the same derivation that they use for the Sagnac effect. So like this is the same situation that they use for ring laser gyros nowadays. So like they nailed measurement and what it should be. Like they fully had a correct scale and all that. So this is just the 2 times the distance that light has to travel, and then the velocity assumed was 30 kilometers a second over the speed of light. And then that gives them the ratio for the wavelengths.
What was lambda? What color did they consider lambda, or they didn't care?
Yeah, they did. It's they included it in the
the
speed or whatever as a function. But yeah, it was an incandescent lamp or whatever. Yeah, they got that measurement there.
I heard
and then
the arm length is the effective arm length is 11 meters. Because they had like they were using mirrors, so D was like 11 meters or something.
Oh, I think it was even bigger than that. I think when you do the whole distance it has to traverse, it's like 64 meters or something like that. Or
How? How many mirrors? I only see 4 mirrors.
It was
how
back
big?
And forth.
Yeah, but how big? Fine. How big was this table? I mean,
it was big.
Is it like
I don't remember
2
the
by
exact
2
dimensions off the top of my head?
It's probably 2 by 2 meters. Probably not even that.
It's significant. Let's see. Demio's got some good pictures of it. Let's see. Or no, wait, 1 second. Miller. If I can find some pictures of it real quick. Yeah, here's one.
Yeah, but
so yeah, it was pretty massive.
Next to a person, where I need to see it next to a person, or if it could just say the size. Anyway, like it.
Yeah, no, I mean it's available. I just don't know it off the top of my head.
It's
the total
probably
link distance. It comes out to 60 meters or something like that.
Is it still there? Is it still at the basement in Ohio?
I can tell you. No, there's some in Case. What's it called? Case Physics School.
So but anyway, so it's one. I see 1.2. Is it? So but we don't know the size. But it can't be 60 meters. There's only 4 mirrors, so it's. If it's 4 by.
Pathlink.
Is what?
The Pathlink came out to like 60 meters, dude.
How? I see 4 mirrors. Show me 60 meters. How do you get 60 meters? I don't have a problem. Fine, 60 meters. That explains why they were able to get.
It's the distance there and back over and over and over and over again.
But you need a mirror. What do you mean? You only have 4 mirrors. You can't say again so many times. You can't reuse a mirror.
The distance that these 4 mirrors came up with was comes out to about 40 meter or 60 meters.
This is really important. I mean,
I mean,
when
if
I
you're
heard
basing your worldview and paper on this, you should know the dimensions of it.
what, based on what?
That you can look up the dimensions for it.
Fine, I could. I'm going through the numbers. Let me think. They got 6 kilometers a second.
Yep.
So the way I view it, the way my ether model is that at the so the way I view ether is gravity for me. The ether
Yeah,
flows
it definitely could be.
right. So if the ether is gravity, that means it's flowing into the earth right now. Now I use just Newton's F equals ma and F equals gmm over r squared, and I do the calculation, and I get that the ether should be flowing into the earth right now at 11 kilometers a second. It should be flowing into the earth. Now, they were not measuring vertically, they were measuring horizontally.
Ooh, have you seen any vertical interferometer experiments? I've got a couple I can recommend.
But did they find anything?
Yeah, so there's 2 lads on YouTube. One of them's name is Martin Gruznik. That guy says that he measured 2 fringes, but his apparatus looked a little shaky, if you know what I'm saying. There was a guy that went to disprove Martin Gruznik, and that guy also measured about 2 fringes while simultaneously looking at everyone in the camera and saying that he measured no fringes, which is super weird. And then there was another guy a couple of years ago named Chris Machado who did a vertical interferometer test. He said that he got 2 fringes, which would correspond to about 10 kilometers a second. Just if you just take 1 fringe from Michelson-Morley being about 5 kilometers a second, 5 totaling 30 kilometers, simple math. So if he measured about 2, would be about 10.
But that means he had a 60-meter arm interferometer. You can't have that. There's no way you can build a like you saw there.
Yeah, so his definitely wasn't no 60-meter loops like that. But again, what was I going to say? That Chris Machado guy doesn't have his stuff publicly available. You have to pay for it, and it's not on any site that I can access it on to even look at his data to see anything about his experiment. He just talks about it during a presentation and shows some video of it. So I don't have any raw data from it or anything like that to analyze or give you.
But this is so strange. You're saying that Michelson and Morley got a positive result, and everyone just keeps saying that they got a null result. They got a Nobel Prize for null result, and you're telling me it was not a null result? What's going on?
It was not a null result. Yeah, dude.
So why did Michelson accept? Why did Michelson accept the Nobel Prize for a null result?
So all these people, right, in the Royal Society all have a core belief. They adhere to the Copernican principle. That is that the Earth has no special place. It's not significant. It's, and to do that, you have to put the Earth in motion. Now, when they took these definitive measurements with interferometry, when you get into the history of it, they knew what they were measuring. That equation, that derivation is not an accident, right? It's spot on because it's still used today. So when they took these definitive measurements and they got a measurement that wasn't 30 kilometers a second, boom, they immediately falsified the Newtonian dynamics applied to the sky, meaning that GMM R squared equation that you listed earlier has no physical meaning because it's just a ratio of constants based off of a periodicity for the event. So there's no, it goes back to that, which is the same as Kepler's laws, where it's just a ratio and a periodicity, which provides the distances for everything. So what was at stake was the claim of, hey, I can tell you why these objects in the sky move, And that's a huge thing to give up. So they had to come up with a way to explain this and keep their model intact, right? Because they have Kepler's laws and they introduced Newtonian dynamics to them. And they were like, well, oh my God, it works. Magically, so this must be it. So this definitive measurement was a direct falsification. Now their conceptualization of it, of the ether and whatnot beforehand, was that the ether was static and the Earth moved through it. But these velocities produced imply that the Earth is either stationary, or the Earth is stationary with respect to an ether drift, or an ether wind, as I call it. Now, if you were to say that it's due to an ether drift velocity and all that kind of stuff, you would have to then come up with ad hoc explanations as to why you didn't measure the full 30 kilometers a second, because in every other case terrestrially, you can measure velocity 1-to-1.
Hold on.
So,
wait.
Yep.
So the way I do the calculation is that at the equator, the Earth is rotating. The Earth like, how fast am I? Let's assume right, so you don't believe it, but let's assume the Earth is a sphere. Like, what's the radius of the Earth?
it would be this. It's the same as they give us for
It's like
what they currently say, because it's all based off of optics. So the radius would be 3959.
The radius of the Earth is 3959 kilometers or miles?
Miles. Sorry, I'm not a metric lad.
Oh my God.
I'm always on the mile grind.
Oh, so it's like, I think it's like 6,000. The radius is like 6,000 kilometers. Okay.
Yeah, that sounds about right.
So 6,000 kilometers. Now the Earth rotates once, like 360 degrees per 24 hours. So I want to convert that to meters per second. So 6,000 kilometers. So we need per second. So how many seconds are there in a day? Anyway, we need to do the math to figure out how fast, what is the linear velocity at the equator? What is a person's linear?
Isn't it like 1,000 kilometers a second, or 1,000 miles an hour?
Let me ask ChatGPT.
Pretty sure it's what it is. You can
What
just use that. Just
is
convert 1,000 to kilometers?
linear
1,000 miles to kilometers.
Let me see if ChatGPT can. What is the linear velocity of Earth at the equator? 1,000 meters per hour. .465 meters per second. So let's assume Ohio is about half that, because Michelson and Morley were in Ohio. Do you remember the name of the town, the city?
Yep, they were in Cleveland.
Cleveland. So I'm assuming it's half that. So this is about 500. So it's about 250 meters per second. And they measured 6 kilometers per second. I cannot account for that. Like, I can account.
Dude, nobody can, bro. That's why it was so devastating, man.
No, it's too fast. It's too much.
I know, but not fast enough, right?
Let me ask you.
Crazy.
No, for me, it's too fast. I mean, I cannot account for 6 kilometers a second. I can barely account for, I would say, 200 meters per second. So I don't know how.
Yeah, that's why
they got a full. You telling me they got a whole fringe, a whole wavelength?
Yes, sir. Yes, sir. And not just in that experiment. These were repeated by a man named Dayton Miller, and Edward Morley actually was Dayton Miller's lab assistant for a number of years. So he continued on the experimentation with it, and they not only reproduced, that velocity component that that was originally measured, but they actually measured. So in the paper, he says here, I closed it, but he says, we should definitely do this throughout the year if things change, because in the heliocentric model, based on the equinoxes, just throughout the year, the Earth is going to be in a different position with respect to the sun, and it's going to be traveling at different velocities, right? Because it has to gradually slow down and then speed up a little bit,
right? But
complete its orbit. So he was saying like we should continue these, but he never did, right? But Dayton Miller and Edward Morley and some other lads continued it, and what they found was that there's a periodicity throughout the day where the minimum and maximum peaks fluctuate corresponding to sidereal time. So when you plot their data against sidereal time, it makes a sine wave. When you plot it against 24 hours, it makes dog shit. And
that's,
in addition to that,
I can explain. No, but I can explain that. I mean, at 24.
There's one more. There's one more thing that he measured too. It was an annual periodicity that corresponds to the position of the sun, where on the equinoxes, specifically, the speed of light reaches its maximum dimensions for velocity, and then its lowest on the other corresponding equinox. So what they measured, right, was the rotation of the stars and the motion of the sun, but not to the velocity that would confirm heliocentrism. So they actually deny Dayton Miller's work too, and they say that Dayton Miller measured experimental air. But what he also found was that when you took the interferometer to altitude, the velocity increases; it gets faster. So in Cleveland, Michelson-Morley was done in a basement in the lab, brick and concrete and all that, and it was done at 200. Cleveland is 200 something feet above sea level. So at 200 feet above sea level, the velocity of the ether is measured at 6 kilometers a second. And then when you go to 1,800 feet above sea level, that's where Miller did the last 5 years of his work on Mount Wilson. And he measured a velocity of 8 to 12 kilometers a second. So,
and did he get? Is there a difference between night and day and stuff like that? And like according to this model of ether wind, it should change if you're right. If you right, the Earth rotation.
That's what produces the measurements, right? So if the Earth is stationary and what they're measuring are fluctuations that correspond.
No, hold on. But there's two types of rotations. There is the Earth 24 cycle rotation and the Earth 365 rotation around the sun. So the 365 rotation around the sun, if you think about the ether wind, that's irrelevant. But the 24-hour cycle, so when it's nighttime, you should be moving faster through the ether wind than when it's noon. Because when it's noon, you should get the slowest ether wind. And when it's nighttime, midnight, you should get the fastest ether wind. Right? Because when it's midnight, according to the sun-centric model, when it's midnight, you are moving the fastest through the ether wind. And when it's midday, you're moving the slowest through the ether wind, right? If you're assuming the ether wind is stationary relative to the sun. I don't know what the assumption is. I don't know what this ether wind assumption is. I don't believe in that.
The ether wind assumption, you're good. So instead of the Earth being moving through the ether causing the wind, the Earth is just stationary, and the ether wind is being translated from the stars and the sun.
Why?
So that's what causes those velocity increases and fluctuations that are measured.
But what causes the ether wind?
Who knows? I mean,
no.
What came first, the chicken or the egg?
No. No, you need a model. Science, you need to come up with a model. You can't just...
I need to explain why the stars are moving?
Yeah.
That seems insane.
Why? Modern cosmology explains everything. Modern physics explains everything. Why?
No.
I mean, whatever you discover has to... What? You have a day off?
Okay. We have measurements directly correspond to the motion of the stars and the position of the sun. Now
Wait.
you're saying that I need to explain why they're moving. That doesn't track. Right?
Wait,
I have no idea why they're moving.
but
I have
modern
no idea what
physics,
drives the ether wind.
but big physics explains everything. Like I
No,
agree.
big physics doesn't explain anything. Big physics has led you to believe that you need to compensate for an expansional redshift. And then you're now attributing
my ether,
dark.
my ether needs the redshift. I had to come up with the redshift, whether I like it or not. My ether, because my ether is gravitational, it flows into the earth. So the universe runs out of ether. I need to resupply the ether. I need dark energy. My model needs dark energy. Therefore, it needs a redshift.
Right. Do you feel like dark energy is an adequate way to explain something to someone? Because what you're invoking here, right? Let's break it down. Is you're saying that there's some other causal mechanism that you have no idea what it is, but you've attached a name to it, dark energy.
Dark energy is
you're
just
using that to hold on one second, and you're using that to supplement causal mechanisms, whereas I just simply refuse to do that. Now, when you get into why you have to explain the redshift of light, well, interpretation of the velocity of it you don't have to agree with or explain. There are many interpretations of why there could be redshift, and simply light moving through a field will have redshift. So you don't need to capitulate to the mainstream cosmology to explain anything or invoke dark matter as a causal mechanism for why something moves, because that just seems insane from my point of view. Right?
Hold on. Look, I started, my journey started 2-3 months ago. I started from just understanding how an apple falls. Just that. So I just looked at Newton's gravitational equation, and from that I got that there is ether, and the ether flows through the apple, and it flows into the center of the earth, and it drags the apple towards the center of the earth, just as it is dragging me towards the center of the earth right now. So that was my beginning, and then I realized, okay, so the ether must be flowing into the earth, so it must be getting annihilated. It keeps flowing, but it doesn't fill, so it must be annihilated. So the universe
has to flow in all directions too, to keep the pressure equal for the globe.
No, it flows. No, it flows into the earth.
How could it flow? How could it flow into the earth from a certain direction and also provide an inverse pressure, keep somebody on the other side of the globe? If the causal mechanism is the flow,
it flows symmetrically into the center of the earth at all times. So it's flowing through me right now, and it's dragging me into the center of the earth. It's flowing through everything.
What about someone that's antipodal to you?
Yeah. It's always flowing towards the center of the earth.
Right. So in every direction, it's an omnidirectional flow to the center point.
Yeah. It flows into the center of the earth. It's dragging everything into the center of the earth, but it's being annihilated as it is interacting with a massive particle. It self-annihilates. The particles of the fluid that make up the ether, as they interact with particles that have a mass, the ether particles annihilate. So the universe runs out of ether. As the universe creates gravity, it runs out of ether. The universe shouldn't exist. It should collapse on itself. So in order to prevent the universe from collapsing on itself, I had to come up with dark energy. And dark energy creates a redshift. So it's like my model fits perfectly with big physics. I don't have a problem with big physics. I just have a different interpretation, but I agree with the math. The math and the observations, all the interpretations of big physics are correct, except for in my model there is this fluid. I could show that in their model there's also a fluid. I could show it, but okay. I mean, but you're
I
like,
mean, they have density in their wave equation, so they're definitely super into a
Yeah.
fluid. They
Yeah.
just don't even know it yet.
right.
But no, I get what you're saying, man, and there's definitely some different aspects to look at it through, because if you try to look at it through the history of interferometry, through the mainstream paradigm, you're going to be missing out on a lot of velocity components. I would like to recommend a book to you. It's called Ether Dynamics by Vladimir Atsutovsky. He goes over the history of these measurements and everything, and breaks them all down.
You have it?
And because yes, I absolutely, and I have the translated English version.
You
I'll
have
send it to you
PDF?
here in a second. Yes, sir. And but basically, what happened here is no one knows the causal mechanism for gravity. Where people get into trouble is trying to attribute a causal mechanism to it, right? So they'll say, some people say it's electrostatics, some people say, you can use ether pressure, and I could go either way on it. Honestly, I really don't care. But the main thing, though, right, with all anyone has ever had is the kinematic derivation for downward acceleration, for how fast something falls, right, at 8 or 9.8 meters per second squared, right? When you get into the Cavendish, which was supposed to establish big G and little g, big G and big M, the mass of the Earth, all that experiment did, when they're considering the mass of the balls, right, they're incorporating the downward acceleration of G to provide that weight. And all it is a torque angle based on that ratio of downward acceleration, which gave them the mythological big G, which is what they established as a constant for the force between the balls and the Earth. And then they took that to for the mass of the Earth, because it's just algebra, so you can backwards derive what the mass would have to be to cause that. So that gave them big M, and then from that they started applying an algebraic shuffle to Kepler's laws, and that's where they came up with how everything moves in relation to its mass, for the motion of the things in the sky. And that's where we get into the significance of the Michelson-Morley and subsequent experiments, because it's a direct falsification of that velocity. As if these things were true, it would produce a force. Like even if you're not an ether lad, you would have to say that this velocity has to be measured under Newtonian dynamics, otherwise there's no velocity. Right? If there's no velocity, then there's no dynamics.
Wait.
If there's no dynamics,
I'm lost. So my ether model agrees with big physics on everything, except for.
But that doesn't.
Mhm.
But that doesn't mean anything, though, right? Because
Why?
what you've
What do you
done.
mean?
Well, because you're building on the back of something that's already been experimentally shown to be false. Then you didn't have the complete measurements of Michelson-Morley and the subsequent velocities. And in order to make your model work now, you're going to have to do the same thing that the mainstream did. You're going to have to reinterpret Michelson-Morley as a null. You're going to have to deny Dayton Miller, Hector Manera, Yuri Galev, all these other people who have done these. You're going to have to make the speed of light, you're going to have to make C equal C, right? Even though nobody measures that.
I don't have a problem. I mean, we should be fine with C. C is the speed of waves in the ether.
Yep. And then also, though, the speed of the ether adds velocity addition to it. So everywhere on Earth, relative to the latitude,
but you can't.
It gets faster as you get closer to the equator.
But you can't.
So nobody actually measures C. They measure C plus V.
But you can't notice it. Except for
no, you can. It's measured in the fringes.
Right, except for with an interferometer. You can only interfere, but you cannot. But everywhere you measure the speed of light, you always get C. You never get anything different.
It
Except
also works with GPS. No, it's always different. It's just to the magnitude of which you're measuring it and
Mhm.
how precise you need it.
Mhm.
Right?
Yeah. But I'm so confused about the 6 kilometers a second. What that is so weird.
Yeah, I got a ton of resources I can give you. So this guy, just from let's see, GPS 4, just from reanalyzing Michelson-Morley itself without even touching on Ian Miller's work and stuff, right? This guy, can't remember his name. It'll come to me as soon as I scroll to it. What's his name? It's this guy right here. Come back to it in a second. But anyway, they had an accuracy of 2 kilometers a second. So like they were well within their error tolerance when this dude did a harmonic analysis of the measurements. What he came up with was that that they're not non-zeros, and that they're statistically significant and shouldn't be treated as a null result, or the speed of light being measured as c. And what's this guy's name? Super unfortunate. 1 second. That's gonna bother me now.
1 second. You've never heard anyone explain ether the way I explain it? No one has a complete model of all of big physics using the ether?
Yeah, I've seen several people try to co-opt it and do their interpretation of it that keeps the Earth in motion and stuff. It's
not
nothing
just
new.
It's not just keeping the Earth. I explain special relativity, general relativity, quantum physics, black holes, dark energy. I explain everything using ether. I mean, everything comes out of ether. Once I assume ether, all of these phenomenon are predicted by my ether assumption. The constancy of the speed of light.
Those things that you listed aren't phenomena. They're conceptions.
Elijah, relax for a second.
Okay.
Wait. Why don't you?
Let's back up. Okay, so hold on a second. You say that when you add an ether to special and general relativity.
No, I didn't do
actually
that.
Falsifying them entire.
I didn't do that. I started from just trying to understand Newtonian gravity. That's it. From Newtonian gravity, I realized there is ether flowing towards the center of the Earth at 11 kilometers a second. Once I realized that, I realized I need dark energy. I realized I need quantum field theory. Everything comes out of just Newton. And you could argue it comes out. I mean, it just comes once you. Go ahead.
You're just doing the same thing that the mainstream did with mass attracting mass.
No,
now you're putting that.
That's not what Newton
now you're
says.
putting that on.
That's not what.
Now you're putting that on dark energy as the causal mechanism for why things move.
No.
Just unnecessary.
That's not what Newton says. Newton says, look at this. Newton says, F equals ma.
We're not talking about Newton, dog. We're talking about why you're attributing G to dark energy to explain everything.
No, but you keep saying mass attracting mass. That's not even correct. That's not even what Newton says. And that's not even what Galileo said. Even Galileo would disagree with that statement.
They disagree with it, but in mainstream, it's attributed as mass attracting mass.
No.
The whole story of Cavendish. This was all
Einstein.
Buddy, what are you talking?
Einstein.
Buddy, we're not talking about Einstein right now. Right? We're talking about Newton. We're talking about mass attracting mass.
No, but you're saying, look, you're saying modern physics.
About big G.
Yeah, big physics.
About big G, big M. What are those? Those are mass attracting.
But there's
mass.
no little m. Little m drops out.
I know.
What do you mean you know?
Indeed.
So it's not mass attracting mass.
Revealing, dude. Well, I'm glad that you're aware of that, because most people are not. Now,
what do you mean?
That's where you get in. Most people think that it is mass attracting mass, and they don't realize that the mass canceling out eliminates it as the causal mechanism for the motion. They don't realize that it's just a ratio of constants over the periodicity which gives
What
them the quote unquote
periodicity?
correct result.
Why do you need
The time it takes for the because everything is covariant with Kepler's laws. So in order for that to happen, those are all just a ratio against pi and the periodicity.
I don't need
Right?
Kepler.
So
I don't need Kepler.
you know,
I don't need.
you actually
I don't need Kepler.
Yeah. No, you 100% do. Everything in the sky obeys Kepler's laws.
I don't. I could have predicted Kepler just by observing an apple falling.
No.
Yes.
You can't predict anything with Kepler's laws. They're based off of empirical observation.
Yeah,
Thus
but
the periodicity. They're not predictive. Nothing in the sky is ever predicted. It's all ratios of periodicity over constants. That's the whole trick.
Right, but you don't need the
Kepler's laws don't predict
periodicity.
a falling
You don't
It's
need
insane.
any data from Tycho, from Kepler. You don't need it. You don't need to look at the sky to predict the sky. You could have. It's predictable once you understand
That's incoherent.
why. Look, let's go through it. So you see an apple falling. From an apple falling, I don't need any of that. It's nice to derive, it's okay to derive Newtonian gravity from Kepler. I don't need it. It didn't need to go that way. Galileo could have done this
Do
without.
you understand? Do you
Mhm.
understand that Kepler's laws are the backbone for
Yes,
everything, and
of
it's all a
course.
ratio of a periodicity?
I understand, but that's
So
history.
When you say you don't need it,
Right.
it doesn't
History
mean
could have.
anything because your agreement with mainstream physics capitulates to this inherently.
No,
You're
no.
not predicting anything.
I'm saying it could have gone a different way. It could have, like Galileo and even people before Galileo. If you just think about why an apple falls, and if you think, well, it must be a fluid, there must be an ether. Then if it's a fluid and it's an ether and there's a flow, then you already get Gauss's theorem and you get the inverse square law. So you get the inverse square law just from observing gravity and just from assuming ether, an ether fluid, an incompressible ether fluid that causes gravity. If you assume that, you already have you have Gauss's theorem and you have the inverse square law. Inverse square law is Gauss's theorem. That's just fluid dynamics. If you just fill the universe with a fluid and you suck the fluid out from the center of the earth or the center of anywhere, that's the inverse square law. I mean, Lenny Susskind goes through this in GR, in his course on GR, Intro to GR. And he actually has the statement. He says, literally, you can view gravity as a fluid flowing into into the mass and dragging everything that's in its path. So even Lenny Susskind says that gravity is a fluid. You could view it as a fluid. Are you there?
Yeah, I'm listening.
So it could have been done just from a thought experiment. You could have predicted. I'm not saying capital G. Capital G, you need to do measurements to come up with capital G. But Galileo did the measurements. He dropped a rolling ball down a plank, and measured the time, and from that you can get little g. But I don't know.
So
from little
as I
g.
stated earlier,
From little g and
that's all
from
anyone's ever had.
No. From little g. What do you mean? I don't need Kepler.
All all anyone has ever had for little g is a measurement of the acceleration.
Right.
Nobody knows why.
But what do you
Right?
mean? If you
And
assume,
when you're
what do you mean know why? If you, it's a theory. I mean, I like ether for me,
in
gravitational ether
in
for me. Go ahead.
the theory of mass attracting mass falsified, right? And then the continuation of it through special and general relativity also falsified.
What do you mean? But special relativity comes out of the ether. Ether
It
predicts.
comes out of a static ether model.
It doesn't.
And it's been falsified.
What do you mean? What's
And
been
additionally,
falsified? What's been falsified?
So there's linear interferometry. So a guy named Ruyong Wang did linear measurements of movement. And then also GPS shows that it doesn't matter if you're moving in a rotation or if you're moving rectilinearly. You still there's still a variance in the speed of light proportional to your velocity directly. So the postulates of special relativity for inertial observers and all that, measuring the speed of light as a constant, is false.
Okay, how do you
relativity
explain?
of simultaneity is false. And big G in what's it called? Einstein's field equations to explain the as you put it, the cubic fluid pressure, like per cubic centimeter or whatever, right, is false because it was falsified by interferometry. When you look at the measurements as they are, right, 6 kilometers a second, not being a null result, you can't build a whole theory based off of on the hypothesis that Michelson-Morley was a null result when it wasn't, and it's been repeated.
I'm not saying.
Subsequent that
Can you show
shows
me
more velocities?
Could you? How did you get the 6 kilometers a second? Can you show me the 6 kilometers a second?
Sure.
Is it in their paper?
Yep. So what we have here, right? 0.05 of a fringe.
Where are
is
you
30
reading
kilometers
from?
a second.
It's
Just right here. I'm just looking at the graph.
Okay.
5 fringes equals 30 kilometers a second, right? So every fringe is 5 kilometers a second or thereabouts, right?
What do you mean?
And when they measured,
how do you know that?
It's it's just basic math.
What do you mean?
Many fringes are in between 5 and 0.
Wait. No, well, all I see is lambda, 0.05 lambda.
Yep, that's the wavelength. It's going to be this is how much fringe displacement there will be.
Sure.
In the wavelength, right?
So we're talking
if 0.05 equals 30 kilometers.
Why?
Then one fringe.
Why? Why do you say
would
that?
Equal 5 kilometers.
Why do you say? Where's your? You just said 30 kilometers a second. Like each fringe. What? Say it slower. Could you speak again slower? What did you say? How do you get to 6 kilometers a second?
Each individual fringe that adds up to 5 has to be about 5 to 6 kilometers.
Why?
What do you mean? Why?
How do you convert to? How do you convert? Yeah, I'm asking, but how do you convert to kilometers? All I see here is in terms of lambda. How do you convert it to kilometers? Where's the conversion? I'm not denying. I'm just asking.
It's up here where they derived how much fringe displacement would correspond to 30 kilometers a second.
Where are they saying 30 kilometers a second?
All of this right here. Right?
Where?
Big V, velocity of light. Little v, velocity of Earth in its orbit. D, the distance that light has to travel over the interferometer. T, the time it takes
to go
there and back.
Okay. Can you show me the actual calculation how you get 6 kilometers a second?
Yeah, right here. QD times V squared over C squared.
Fine. Can you plug in the numbers and go through the actual and just... Is there a paper I can read that explains how to get to 6 kilometers a second from this raw data?
Yeah. So if the fringe displacement for 5 is 30 kilometers,
Why?
could
Why do you
just
keep
deduce
saying that?
Dude, stop, dude. I'm losing my patience with you.
Look, I don't want to bother you. Like I'm really curious. So I mean, if you feel uncomfortable,
Eric, can you help me out here? I don't understand what to say to you to make you understand it.
Look, I don't want to bother you. Honestly, I mean, I don't want you to get upset. I'm honestly curious. I'm writing papers on the topic. The 6 kilometers a second for me is something I cannot. This is out of left field. I can live with 200.
They go on to say, right, that the displacement was proportional to the square. Right here above this actually. It says the distance d was about 11 meters, or 2 times 10. Oh, my bad. You're right. It wasn't 60. Miller did the bigger one. Was about 11 meters for d. So, anyway, they right here. So since the displacement was 0.4 of a fringe, the actual displacement was certainly less than a 20th of this part, or less than a 40th. They're telling you how much it was measured right there.
Where? Fine. How do you? Yeah, but how do you get the 6 kilometers a second?
Just basic arithmetic, dude. If 5 is 30, then 1 is like 6.
Okay. Where do you see that 5 is 30? Where does it say that 5 is 30?
Whole fucking paper is that.
Wait, can you show me, please?
What do you mean?
Look,
Alan, I have a suggestion.
Right here, dude.
Where? Show me the word 30. Can you show me 30 kilometers somewhere?
Right here, the velocity that they use to derive the prediction for the fringe displacement. So when you solve this equation, it tells you that there will be 0.05 of a fringe, and that will correspond to 30 kilometers a second.
Oh, okay. So now I understand. Okay. So that's 30 kilometers a second, and you're saying they got 1 out of 5, basically. So it's about 6 kilometers a second. Okay, now I understand.
Over 1.
Okay.
Yeah, sorry about that. I was like, how is he not getting it? What's happening? And it was starting to frustrate me. I apologize.
I'm sorry. Okay.
You're good. It's mostly my fault.
And how many times did they conduct this experiment? Because I only see 2. I see 2 graphs.
So they only did 6 days, and they redefined all of physics based off of this.
So they conducted this experiment 6 times? What do you mean 6 days?
Over the course of 6 days, that's what all these measurements are from.
So over 6 days, it's 6 experiments?
They took measurements throughout the day for 6 days at different times a day.
And
like you were saying, when it's noon and midnight, you should be experiencing minimum and maximum velocity shifts. That's what they were doing.
And so how many experiments did they run altogether? Like, what are we looking
in this
at?
Particular run, this was only 6 days.
I see it says here noon observations and PM observations. So isn't noon what PM is noon, isn't it? So they didn't do
it's
midnight.
later in the day. So,
and they did, July 8th, they ran it, 16 times on July?
I got a breakdown of their time and measurements. 1 second.
Okay, I'm lagging, but Alan, I'm lagging in the assistance here, but in the main chat, I posted the calculation to get 30 kilometers per second. It's simply the Earth's orbital radius times 2 pi to get the circumference divided by the number of seconds in the year, and you get like 29, which is close to 30 kilometers per second.
Yeah, I understand. I just wanted to know where.
Well, yeah, you don't need a paper for that. It's just the basic.
Of course. I was asking, where is this number coming from? Now, I'm not denying the 30. Once I understand where it's coming from, it's fine. I know that the Earth is moving at 30. The assumption is Earth is moving at 30 kilometers a second. The question is, how? Like, we're looking at one graph or two graphs. They show two graphs in their paper, but so they only drew two graphs, but they ran 16 experiments per day for like 10 days, but they only drew two graphs. Like, I need the raw data.
Yeah, I mean, no one's gonna get it. No one has it. All they have are those that's published.
So, are you guys running? Is anyone running an? Is anyone thinking of running an? Because I'm writing a paper how to run the Michelson-Morley experiment. Like, I'm writing a paper to explain why they got a null result. Because according to me, they shouldn't get anything. No one should get 6 kilometers a second. I told you, they should get 200 meters per second. But that's not something that their equipment was capable of detecting. So that's why That's why I would have predicted a null result. That's why I'm saying I want to see two graphs is not enough. I need all the raw data, and I need all the raw data of anyone who tried to reproduce Michelson and Morley. I need to see everything, because my prediction is 200 meters a second, no more. In Ohio, and 500 at the equator, 0 at the North Pole.
Yeah, Dayton Miller obliterated that, and then there was another one done with in Kharkiv in 2000 by a guy named Yuri Galev, who showed that there was a vertical velocity gradient as well. He actually substantiated Miller's work.
Okay, let me ask you. So
it gets faster.
Okay,
go ahead.
So according to me, we should be able to build a very, very, very big interferometer. Like basically a kilometer arm by using fiber optics. So by using and I'm writing a paper about exactly how to build it. So by using like a kilometer of fiber optics, you could use your desk at home, put it on wheels, just buy 4 wheels at Ace or wherever you buy your wheels for your desks. Anyway, take a desk that has wheels, get a kilometer of fiber optic cable, not even cable, just optic fiber, and you should be good to go. I mean, just build an interferometer. The problem is, like, to purchase a kilometer, I looked at the prices on Amazon. 100 meters of optic fiber is $300. 100 meters, and we really should go for 10 kilometers. 1 kilometer is not enough. Anyway, it ends up.
Is this uninterrupted?
Yes,
well, I'm going to interrupt if I make a quick comment here. There have been researchers recently, and I've told Alan about it, is that just to use interferometry to detect the Earth's rotational motion, not orbital, but rotational, they had to build a large interferometer, and the data analysis was done using LabVIEW, and they presented all their data. If you want an example of all the data, interferometry data is available at the Nature's website. Nature is where they published. And there's a lot of noise, and if you scale it up to like a kilometer, you're saying, trying to detect the Earth's orbital motion, that's going to be, I mean, let me just say, if they had difficulty detect, or they had to extract noise just to detect the Earth's orbital motion, I mean, rotational, orbit around the sun is going to be so much smaller. It's going to be challenging to detect that, even if you have a kilometer.
Right. So I'm aiming. I'm aiming for 10 kilometers. It's going to cost about $100,000. Yeah, it's going to cost about $100,000 just for the optic fiber.
Well, yeah, but I'm saying that it's even the analysis of the results are going to be they're going to be difficult because there's going to be noise.
Yeah.
And
that's why I'm aiming for a 10-kilometer arm, but it could fit inside your home office. That's the beauty of, but it's just going to be expensive to invest in so much optic fiber. Plus, you need to build a rig to spread it. You need to build an interferometer out of 10 kilometers of fiber. It's a lot of
Just
work.
10 kilometers of uninterrupted fiber.
I mean, you could have I'm sure there's connectors. I'm sure there's fiber connectors, optic fiber connectors. You also start with
I'm going to send you
Not seem practical.
papers to check out later, and then you could use search.spaceaudits.net to find all the papers. We have them all accessible there. So any of them you want to look at, just type in the name. I'm going to start sending them to you so you can check them out.
Just give me a link.
Yeah, well, I gave you the link, right? And then I'm sending you like the names of what to look for using that link.
Okay.
We built a library for you. Have fun.
Yes.
All we need now is like a virtual UI. Step into the matrix. Eric.
The question is,
I'm here, but I keep putting myself on mute here.
That's all right. I was just wondering if you got any time since we last spoke to peruse any of those documents that we were discussing the last time.
Oh, unfortunately, no, because I'm working on something for work that's kind of taking all my time. I did download the book by, is it Linderman? And I did find some other references, but I need some free time to study these in detail.
Yeah, I understand. No worries.
like this 6 kilometers an hour that you say that they got, Michelson and Morley. So how many times did they get it?
Well, they only did 6 experiments over 6 days, different times of the day.
And they always got 6 kilometers, 6 kilometers a second.
Well, when you look at their graph here, like it fluctuates, based on the time of day. But yeah. So
this wait, can you pull up the graph again? What are we looking at in this graph? This is all the data over all the 6 days?
Yep.
So it went
These are the
up
minimum and maximum peaks.
It went up and down during the 6 days? Or so show me could you show me the first day, for example?
I don't know how that would work.
That's my question. I
assume that it would just be starting here and then next day.
So it's 1, 2, 3, 4, 5, 6. So why is there? And they ran it twice. So like on the first day they got this, then, and why did they expect it to go up and down like that over 6 days? What happens?
Because based on Earth's, rotation, they would say that you're being in alignment versus not in alignment with the direction of motion
over 6 days.
When you're in alignment with it, on those specific times, you would be experiencing velocity addition.
Wait.
So it would be like Earth rotation plus,
Wait,
the velocity of the Earth through space.
but over 6 days, what changes over 6 consecutive days? 8, 9, 11, 8, 9, 12. I see 3 days.
Well, that was just repeating. That was just
Mhm.
repeating it to see if it was like like experimental error or environmental or something like that. It was like to establish when they thought they would be in alignment with that velocity to get the velocity addition. That's when they were doing the measurements.
But why over 6, right? You're saying that, right? Show me day 1, day 2. Like, I'm assuming each edge is a day. So the left edge, the leftmost point is the first day. Then you have an edge, that's the second day, another edge, that's the third day, then another edge, fourth day, another edge, fifth, another edge, sixth, and another edge, I guess seventh. I don't know how many. Could you just, because you can't see my mouse, so could you tell me which day is where? Like, what are we
starting with the first here,
like?
and second, third,
My question
fourth?
is,
I don't know.
my question
Never thought
is,
of it that way.
so
Don't know.
I mean, but we need
Don't
to.
know.
Right. So we need to understand exactly how to reproduce this graph. I mean, what does this graph say? This is very important for me.
Well, it's something for you to figure out then, I guess.
So the fact that it goes up and down is weird. There's no reason over 6 days. Like I don't get it. I just don't understand it. And why did they expect it to go up and down? What's the expectation? Like, they show a sinusoidal curve. Why?
I just told you when you're in
Mhm.
alignment and not in alignment with
Over 6 days. What changes over 6 days? I don't get it. Like, I can understand midday and midnight. That's fine.
It's Earth rotation, bro. It would be related to Earth rotation.
So it's midday and midnight. So midday, I expect the slowest. Midnight, I expect the fastest. Is that it? Did he just kick me out of the server? He just... What's going on? Is this the server? This is Earth Awakening? Did he just kick me out? I don't get it. These people. What is this? What is this server? Was I here before? I don't think I came to this server. Anyway, I have to go eat. Wow, what a rabbit hole. Holy Jesus. Wow, these people are so sensitive. What is this? Live stream, live on Rumble, YouTube. What is this? Earth Awakenings. And this is Globe. Is he here? Omnivore is here, but okay. So what's his name? Seal? Soul Seal? Don't remember his name.
Who's you?
Hello.
Who is your daddy? And what does he do?
He teaches the globe.
He has a globe blog.
talking about up until I got here? What's going on? What's the crack?
We're talking about keyboards.
Oh, okay. I'll just
I'll get rid of it.
I guess he got the keyboard.
Does anyone know Alan from the Ether?
Know him?
What?
Know him? I don't know him. I know of him.
I think he just banned me. I just spent like an hour talking to him.
Yeah, that sounds right.
So at the end of the hour, they just ban you?
You
What are you guys
probably
talking
embarrassed
about?
What?
Who are you talking about? What character?
Alan from the Ether server? I don't even know the name.
Dude.
Ether?
Yeah, the bear. Yeah.
Yeah, the bear.
He bans everybody. He banned
Why?
Morty. Me, he banned a long time ago because I broke his heart. But he
Why?
bans everybody. He banned his own mother.
Why?
He's a snowflake.
Oh my god.
He banned his mother?
Yeah.
Oh my god. I mean,
what the hell?
Brenda, do you take everything literally every single time?
No.
Oh my god.
No, he didn't ban his mother. He doesn't have a mother. He was born out of ether.
Oh my god.
He banned Ether.
He banned the Ether too. I just spoke to him for like over an hour. We went through all the details of Michelson and Morley, and I had so many questions. But at the end, I guess I was asking too many questions. I'm just trying to understand.
That's why he bans people. He doesn't ban them for like being outrageous or whatnot, just for asking questions.
Like I'm just trying to understand. Oh my
Who's
god,
that?
Alan.
No,
yes.
It's not for it's not for understanding.
So what is it? What's motivating him?
It's for you to tell him how smart he is, how wonderful he is,
My
and
God.
gosh darn it, people like him.
Wow.
Who,
And
who's guys talking about?
God,
Alan.
Bacon.
But he's
Alan from Ether Cosmology.
Yeah.
Okay. It was different for a second. Okay, now I know.
So he's a flat earther.
Yeah, he banned me too.
Oh, he banned you too?
Yeah, he banned Bacon. Can you imagine the nicest guy in the universe?
So
After
he's
Jesse.
but he's a flat earther.
I was gonna say.
Is he a flat earther?
Of course.
Oh yeah. All right. Now,
Wow.
Peter, when you say Bacon is the nicest person in humanity, am I supposed to take that one literally?
I didn't say in humanity. I meant like in Blow Gangsters, maybe. Let's
Okay.
let me
All right, that's better.
qualify it more.
I probably would agree with you.
Oh my! So he says,
thank you.
okay, but his main contention was that Michelson and Morley did not get a null result. That they got, instead of 30 kilometers a second, they got 6 kilometers a second. Do you guys know anything about that?
We know everything about it.
Okay, tell me.
What they got was below the tolerance of the instrument.
Oh, that he didn't tell me. He's too smart, you see? He knows. Oh. So it's nonsense. They got noise.
Exactly. Yes.
Yeah, and he didn't tell me that. I kept asking, and that's why he banned me, because I kept nagging on that point, because it didn't make any sense. I kept asking again, how could that be? Oh my god. Because look, I have an ether model, but according to my ether model, they should get 200 meters a second, not 6,000 meters a second. So 200 meters a second is way, way below the tolerance of the equipment. And I was like, whoa, how could they get a real... And he got, I mean, Michelson got the Nobel Prize for a null result. 6 kilometers a second, that's not a null result. That's a fifth of the... Anyway, so he's a liar. Oh my God. So he doesn't believe what he espouses. He knows he is a liar. Oh my God. Wow. He's worse than big physics.
Big physics?
Yeah, that's a term I came up with like last couple of days. Big physics. Big physics is after us.
Interesting.
It's a joke. Of course, there's no big physics.
Of course.
I mean, it's mainstream.
I'm just doing what Peter told me and not to take things literally.
Oh my God. Oh my God.
Especially when it comes to physics.
Absolutely.
Wow. So he managed to fool me. Wow. I was like, my entire model is collapsing right before my eyes. How can I'm not going to be able to explain this. Wow. And then he banned me. I was like, why would he ban me? I'm asking a simple question. I'm being so gentle. And I kept saying, I'm so sorry. I'm so sorry. I'm just trying to understand. But boom, suddenly the server is gone.
Yeah, that's probably why you lasted as long as you did, is that you're very polite.
I was super polite. I was so polite. Oh my God. So this
even more polite than Bacon?
Yeah, I'm the most polite person in the universe. I'm Mr. Slave.
After Jesse.
I'm a slave. So, but this is unbelievable. Okay, so at least right, because I remember I looked into it a while ago, and that is what I saw, that they got numbers below the tolerance of the equipment. So it's just noise. And he couldn't explain it. I asked him, could you explain to me the graph? He pulled up the actual paper that Michelson submitted. And I asked Alan, could you please explain to me the graph? Could you explain the points on the graph? Could we? And he said, you should look in. He told me to look into it. And I said, okay. I just said, we really need to be able to reproduce this graph. And then at that point, he banned me because I just said we need to be able to reproduce the graph that they drew. Like, what is that graph? Anyway.
Yeah.
So I do believe in the ether. Does anyone have questions?
What do you mean
No,
by the ether?
we believe in ether too.
Wait, what?
You're in a safe space.
Wait, but somebody here said they have a question.
We don't have any questions.
Wait, what? I'm not gonna ban you if you ask me questions.
We don't need to ask you questions. You said you believe in ether. We believe in ether. We're all friends.
Wait, you believe in ether? But okay,
Yeah.
so
Why wouldn't I?
What's your evidence for ether?
It's a medium through which things propagate, right?
Okay, so why did Michelson and Morley get the null result?
Because they thought the ether was different than it actually is.
Namely, how is it really?
Well, they thought it had certain properties, and it doesn't have those properties. It has different properties.
What did they?
Strawman the ether, basically.
They what?
No. There's no need to introduce fallacies yet. Just Michelson Morley showed that the ether is different than most people thought it was and what it was. So easy peasy.
Wait. So how were they wrong? I mean, shouldn't an interferometer be able to? Shouldn't you get an interference?
Yeah.
Okay.
Yeah, if the ether was the way they thought it was, it should, but it's not the way they thought it was, so it doesn't.
Yeah, they thought that two light beams perpendicular to each other, that the ether that would slow it down in one direction, that there's a preferred direction. As it turns out, there's not a preferred direction.
How's that possible? How could you say that there's not a
Well,
preferred?
the reality is just that way. Ether is just that way.
No, but you have to.
And not the other way.
Wait, but you have to explain it. I mean, at the end of the day, the ether is a mechanical fluid through which.
Well, apparently it's not like a fluid. It's different.
What do you mean? How could it be?
It's different.
What do you mean? I mean, Maxwell's equations describe the ether. Those equations describe the ether, so we know.
No, they describe the propagation of electromagnetic waves
through the ether. No.
Through everything, yeah.
What do you mean through everything? But through the ether.
Well, ether is always there.
Fine. So Maxwell's equations describe the ether.
No, they don't. I'll show you which equations describe the ether.
But Michelson was able to create a wave equation that has the speed of light. So that wave, that's an electromagnetic wave through the ether.
Yeah.
And light is an electromagnetic wave through the ether. Yeah? I put that.
Yeah.
Okay. So there is a preferred direction. If the ether is moving one way or the other.
No, there isn't.
Wait, but if light moves through the ether and the ether is moving in some way, then you should get an interference pattern.
Yeah, that's what they thought, but it's not like that. That's why they got the Nobel Prize.
Explain why. Why would it not? Explain the.
Read the slides.
Which
Troll.
slides?
Read the slides.
Wait, did you just
Troll.
call me? Wait, you calling me?
Yes, I did.
You calling me
Read
a
the slides. Read the slides.
Wait, did you call me a troll?
I did. Now read the slides.
I thought only Alan is the problem. So what's going on?
I am Alan's evil twin brother.
Oh, no, you're his twin. If you're not even evil twin, you're just his twin. What do you mean? Read the
You're about
slides.
to get the ban.
You're gonna ban me?
Hey, Rich, how are you doing?
Yeah.
Wait.
Nobody is getting banned.
Okay. Wait. What do you mean? Read the slides. Okay. I'm looking at the properties of ether when matter is present.
And one thing, and you don't have to call him a troll, Peter. That's unnecessarily.
Oh, omnivore, please.
He's a troll.
I'm a troll?
I don't think he is.
I'm writing
Well, he
papers.
doesn't engage in a conversation. He's a troll. You're a sucker for trolls, Omnivore, so you would fall for it. I won't.
Wait,
Yeah,
I'm
you
right.
could say that, but I'm just telling you how I see
I
it.
could say that, and I just did say that.
Wait, I'm writing papers. I'm writing a paper on Michelson and Morley. Here, I'll send you a link.
You're writing a paper. Oh,
Yeah.
let's have a look.
Here. Is there a
Docs.
C? Yeah, is there a person named C-Line or something on the server?
Yes, more than one. Yeah, he's the server owner.
Okay, so I was talking to C-Line about my papers. We decided to collaborate. We're going to collaborate on these papers.
All right, 1 second.
I mean, I just started writing this paper. Here is my other paper that I submitted to C-Line to review, and he liked it. He couldn't find any fault with it.
Yeah, got a first comment in there. Why is your introduction written like how a child would write it? There we go.
Which one?
Here we go. Just add this. We may just add all of it. 1 second.
And here is a paper proving from ether I can prove that the speed of light should be a constant.
Second. So, right, comment here.
That's the same ether that Peter believes. So
Which Peter?
The one that
The one
used
that told you a troll.
Alan's evil.
I added a comment in the bibliography. Why is your bibliography written before the paper? That's the other one. Let's see what else we got.
Yui is our resident academic here.
Oh, that's good. I need feedback. I mean,
right. I'm just gonna do another one here. Untitled diagrams. There we go.
I need feedback just to motivate me to write my papers.
Have you ever written a paper before?
No, these are my first papers ever.
Who's teaching you?
I have a friend. Sinus is a friend who he's not teaching. I mean, we're looking at papers. But look, this is
Here's another one. Why are you doing your abstract first? Do it last.
Okay.
You know what? Just the title itself. Stupid.
Okay.
There you go. Look, you're getting all these comments. I'm so helpful.
Thank you. That's terrific. That's amazing. I'm so happy. Thank you so much.
This paper is proposing. Is this your introduction?
Yeah.
Oh, Peter, I'm sure you've written a physics paper. This isn't how you write a physics paper, is it?
You're asking Peter?
I didn't look.
You should look. It's comedy gold.
Well, usually you start by knowing how to spell the name of Morley.
I didn't even notice that. I was just going for I was going more structural.
A dear friend of mine who became a lawyer, successful lawyer, once handed in an English paper on Westminster Abbey. Where it was a perfectly good paper, but he got 5 points taken off every time he mentioned the misspelled name of it.
So, I mean, we've got a stupid title. We've got an abstract written before you even finish the paper. I mean,
Look,
that is honestly, of all things, I can't decide which one's more retarded. Starting with the abstract, or having the bibliography written before the paper's written. That is also genius.
Well, wait a minute. If you're using all of the books that you've referenced when writing your paper,
You don't know that. You don't know what the put it this way, right? When you write a paper, you do not even know what the title's going to be, right? You write it and you decide the title later, right? Am I right, guys? Say I'm right.
That's correct.
There you go. Thank you. You're right. The title is like one of the last things you do. The abstract is the last thing you do.
I can agree with that. But I think that if you have a running bibliography, I don't see what's wrong with that.
If you put something in your bibliography and you're not going to use it later, what do you do with it? You forget it because it's already in your bibliography. You don't even know that what you put in is actually what you use or not. It's just now in there, right? You use it at the end.
Unsourced sources in your bibliography already is a really bad sign.
Yeah. So all these, you've done all the things you do last first, right? And the only things you're supposed to do first, you haven't even started.
There's
he's
using the
Right, I guess Omnivore's your the guy who's giving you the pointers here because.
Wait, but what paper are you
the
talking
sovereign citizen of paper writing?
I'm just saying it doesn't have to be.
This is how it has to be because I promise you, if you do it this way, it will sound even stupider when it's finished, right?
Yes, but there are ways to give criticism that could be a little bit more constructive.
Yeah, I'm completely lost.
This is constructive. Delete all of this and start again. That's constructive.
We would like to have people come back to the server.
Delete all of this. Start again. There you go.
Wait, which paper are you talking about?
Wait, which people?
No, which paper?
This one. What you said?
I sent 3.
Oh my god! Let me look at the other ones.
He wants to.
Yeah, they want to. We will demonstrate that this gravitational ether is flowing right towards the surface of the Earth at around 11 kilometers a second. It's a nice one. And then calculation. Start with Newton.
11 kilometers a second.
You know, actually, for your second paper, I know the title's an ether flux gravitational theory. I don't mind it because it's obviously just a working title, right? And you can tell you don't know what you're doing yet, right? Calculations.
And the question then becomes: how am I moving my hand right now through this fluid, and how am I not burning up while traveling 11 kilometers a second through this fluid? Good question.
The fluid obviously interacts very weakly with matter.
Just gonna do the Untitled Diagrams shtick again 1 second.
Yeah.
I mean, that's not
And
even
then the nice
that's not
paint
even the worst
diagrams
part of
again.
it. Yeah, that's not even the worst part of it. If it's moving at a constant velocity, that means the force that it enacts on matter, it changes with the velocity that matter is moving, which we know gravitation doesn't do. So it doesn't make any sense.
No, it doesn't.
I'm not going to argue with that. I think that's probably there's probably not a better way of saying that, but yes.
Wait, what?
You know what? I think, right, what you should do. I don't know if Mr. Slave is a troll, right? Could be, right?
No.
But
I talked to him for a
Mr.
while,
Slave,
and
how
I don't
about
think so.
how about like we've got an actual guy who's like such a nerd he would take out the time of his day to look into this, right? Do a research proposal first. Send it to Peter or Totoro, right? Have them read it, and then when they say don't write it, then don't write it. You know, it's foolproof.
I think he should send it to you.
I don't think I'd understand it even if
But you've got the chops to at least know the formal part, like the structure.
Yeah, but that's like proofreading the actual essay. It's not so much the research plan, you know.
And clearly too much time on your hands.
Oh, I mean, this isn't much time to like highlight all the graphs and say why aren't they titled.
Too much.
So a massless object can be used to calculate this ether force. Well, so what I had.
A massless object, is that somewhere in there?
Yeah, so notice that the test mass particle does not need to actually have mass, meaning that even a massless light photon can be used as the test mass particle, which means that you don't need to test mass, but rather test particle, be it massive or massless. This is what Newton claimed. Notice this claim is based on empirical data from Kepler and Tycho, which already says that a light beam should bend under gravity.
The worst thing
massless.
is,
how does this ether work then, if it's not tied into mass?
It's a fluid that fills the universe, and when it interacts with a massive particle, it annihilates. And creates.
It annihilates.
Excuse me?
Could you repeat that?
Go ahead. Sorry, keep going.
So it's the universe is filled with a fluid called the ether. When the ether interacts, comes into contact with a massive particle, it self-annihilates and creates an ether vacuum.
Annihilates as in like annihilates as in annihilates in terms of like antimatter and matter.
The ether is a fluid. It's composed of tiny particles, and what we call elementary particles, those are waves in the ether. So quantum field theory is quantum ether theory according to my unified field theory. So for me,
wait, you came up with a unified field theory.
Yeah, this is a unified field theory that's based on ether.
Wow. Nobel Prize next.
Yeah. Well, he's trying, right? It's a nice little game we're going to play.
So, were you... quick question. Were you stoned when you wrote this?
What do you define as annihilation? Do you mean annihilation as in like matter and antimatter annihilation, or?
Well, the ether particles just cease to exist, and they come into existence through dark energy. So the ether is always.
Can we go back like 10 seconds ago when you're like, what was that about? Why didn't you even answer that?
How exactly does the ether annihilate when it interacts with a massive particle? It just annihilates.
Well, yeah, but what do you mean by annihilate? Is what I'm asking.
So. It just ceases to exist. The ether particles that come into contact with a massive particle just cease to exist, and an ether.
There's no conservation of mass in the ether world.
Right.
So, when they annihilate, do they produce any? Does it produce any energy as a product of the annihilation, or is the energy just gone?
That's the Higgs mechanism, and it produces inertia. It produces mass.
Wait, so the annihilation of the ether is what mass is?
Yes, the mass
Is there a
of.
finite?
Hold on, it has to interact with a massive particle in order for that to happen to produce the mass.
Sounds kind of circular.
No, I mean what we call so it interacts with a particle like an electron. It doesn't interact with with a photon. So it's just the Higgs mechanism. The annihilation is related to the Higgs mechanism. So I think.
Have you derived this mathematically?
You mean? Yeah. Do you mean the Higgs field or the Higgs boson?
So I don't have. I don't have the Higgs field. The ether is the Higgs field. The Higgs mechanism.
Also the ether.
The ether has the Higgs mechanism in it. The ether is my quantum field. All the elements.
So the faster an object moves through the ether,
the less it interacts with the Higgs mechanism, which is the ether.
What I'm curious about is when you say that a particle gets annihilated, do you mean like the mass? Do you mean that the mass gets transferred into like just energy as we know it?
No.
Or does it just completely cease to exist, like entirely?
Completely.
He's saying the ether particles get annihilated.
Yeah, the ether particle. The ether particles are
does-
much smaller than an electron, because the electron is the electron is a wave in the ether field.
How does that work with conservation of energy?
So there is no conservation of energy as far as the ether is concerned. It flows into massive. It's flowing right now into the Earth and is self-annihilating as it is flowing into the Earth. Now the universe should run out of. The universe should run out of ether very quickly. So in order to balance it out, I created dark energy. So dark energy is just the spontaneous creation of ether everywhere simultaneously, and that's the positive pressure. So where the ether annihilates, you get a low pressure of a vacuum, and then you have a pressure gradient, and that's the cause of the flow. So the reason why the ether flows right now into the Earth is because it annihilates as it interacts with the Earth. And the reason it's flowing from the space is because there's positive pressure everywhere because of dark energy. And that's also causing, the rest. I'm completely conformal to all of big physics.
Except the velocity part.
What do you mean?
That didn't really make sense.
So, yeah. So you're saying, why does it not make sense?
Okay, so if the ether is flowing into the Earth at 11 kilometers per second,
yes,
that means an object's velocity relative to that ether would determine how much force is applied to that object. That means if that object is moving in the direction of or against the direction of the ether, we should measure a different force being enacted by gravity, and that doesn't happen.
It's just gravity.
Oops.
No, the ether is just gravity.
But you said it moves at 11 kilometers per second.
So
either it is gravity or it isn't. I'm asking questions about kinetic energy. We already know that conservation of momentum doesn't exist in the ether world, so that's just null, right? You don't have to worry about that.
And as it annihilates, it creates mass.
That's just the Higgs mechanism. The creation of
the Higgs mechanism is an object moving through the Higgs field, though.
Doesn't have to move. it just interacts with the Higgs mechanism. Whatever the Higgs mechanism is,
it doesn't have to move.
Right. Whatever the Higgs.
What happens to an object moving through the Higgs field?
It bounces back and forth and gives the illusion.
No, it does not. The Higgs, as they move through the Higgs field, that's how the particles get mass.
that like an electron, as it moves at the speed of light, it's just bouncing back and forth.
Bouncing back and forth. Well, it's kept in an orbit around the nucleus due to the protons.
But let's take a free electron in an electron beam, or in an electron experiment where we're shooting one electron. So that electron has a mass. That electron travels, let's say, at about 1% the speed of light. So it doesn't travel at the speed of light. I mean, it does travel at the speed of light, but because of the interaction with the Higgs, it's bouncing within the Higgs, and that's what's slowing it down, and that's what it's giving the illusion of mass. I'm just saying, I don't know. I mean, I'm just quoting how I was explained the Higgs mechanism. I'm just saying that my ether has the Higgs mechanism built in. However the Higgs mechanism works, I'm just saying the quantum field from quantum field theory is the ether. For me, it's just the ether. So whatever you want to say about the Higgs, I just say whatever you say about the quantum field, I just say about the ether. It's just, and that's all.
So basically, the only thing you do is changing like the Higgs field, the Higgs boson, and other thing, and gravity. You just change the name to ether.
Yeah, whatever we say, your answer is ether.
No.
Just a quick side question. Have you been reading a lot of Ken Wheeler?
I don't read.
Okay. Have you been listening to Ken Wheeler?
No, I don't listen. I just study physics.
Gotcha.
Then you read, don't you?
It's mostly YouTube. It's like I listen to lectures on YouTube.
So then you do listen.
By who?
Like
an example?
Big physics. All the big physics.
Like Sean Carroll?
Yeah.
Roland Strauss? Roger Penrose?
Yeah. No, I don't like
Ken Wheeler.
I don't like Penrose, but Sean Carroll, yeah, he's good. But Khan Academy.
Yeah, and he speaks about the ether, does he?
No, I don't follow. I follow everything.
Which ether cosmologist do you listen to?
I don't listen to. I didn't know
Neil deGrasse.
He just got banned by Alan.
I didn't know there is an ether cosmologist. I thought I was the only person that talks about the ether in the world. I didn't know anybody.
Toro, check this out. He got banned by the daddy of all ether cosplay.
Yeah.
The leader of the ether cosplay boys, Alan, just banned him from his server.
Yeah.
For being too much into ether. For fetishizing ether the wrong way.
Yeah.
Did he say why he banned you?
It was when I was asking questions about Michelson's paper. I asked him about the graph. How exactly did Michelson produce the graph of the data? And he said, I don't know. And
With Desmos, of course.
What?
Said with Desmos, of course.
Yeah. Anyway, look, I mean, I think that my ether theory is very explanatory.
Yeah, you nailed it.
Stop.
Can you make me an ether battery with this conservation momentum magic thing? It's pretty cool stuff.
I mean, why do you have a problem with the annihilation? I mean, at the same time, ether is spontaneously producing more ether. Everybody agrees that there is positive pressure from lambda from dark energy.
You got it, man. You got it. Just
everybody
fix the grammar. Take the feedback from UE.
Everybody agrees.
Just,
stop. Everybody agrees.
File.
Stop.
Save to PDF.
Stop.
And there you
go. Stop. Okay. Everybody agrees dark energy creates space spontaneously. So
How fast does the ether go?
Yeah, we all agree.
How fast?
What is the speed of the ether? Yeah, what is the speed of the ether?
It's at 11 kilometers per second right now.
Slow.
Oh, that's pretty slow. That's like that's very.
Is that and is the speed constant everywhere?
No, it's as described.
It's in the direction of the etheric wind.
No,
Okay,
there's
if
no-
this is not trolling, what I will be doing now is also not trolling. Okay.
Hey.
Hey, so what is this special education school where kids come in and we have to be nice to them, but the teachers cannot do the same back? Is that the idea?
You don't have
exactly.
Look, you don't have
Oh,
to be
okay.
nice. You don't have to be nice to me. Just please don't waste my time. So, like, if you want to ask
Dude, you're
questions,
wasting our time. You're
that's
just
fine.
laughing us in
That's
ether
fine.
cosplay board.
Look, it's fine.
Yeah, I think there may be a good deal of time wasting going on, to be honest. But you know,
what else are we gonna do?
I wonder how did you measure the 11 kilometers per second?
It's from Newton. So if you take F equals ma and F, it's directly from Newton. F equals ma.
F equals ma equals 11. Got it.
Yes, please. How did you come out with kilometers per second?
Oh my god, you
MA?
guys are so funny.
Oh my god.
You're so funny. I'm having such a good time. Please don't ban me. Just for the laughs, please don't ban me.
No, it was a good joke.
No, but hold on, I want to hear
Good
this.
joke.
I want to hear this. So, how did you get it from Newton? I want to hear this.
Okay.
It's in the chat.
So from Newton, I have the equation in front of me right now. So you take F equals ma, and you take F
You
equals.
solve it.
Yeah, just
It becomes
let him finish. Let him finish. You asked a question. Somebody asked a question. Let him answer.
Okay, you take F equals ma, and you take F equals gmm over r squared. So the m's, and then you equate them. F equals f. So ma equals gmm over r squared. So a equals gm over r squared. So the little m drops out. So already you see that light curves. So already
Hey, where does 11 drop in? So little m drops out. Where does 11 drop in? Tell us.
Anyway, that's the equation for acceleration. So you integrate and you get the equation for velocity. So velocity, which is very similar, of course, to the Schwarzschild equation. So velocity is equal to 2gm over r square root of 2gm over r.
Nailed it.
Mr. Slave, I need you to define some terms. You mentioned r squared a couple of times. I know what r is, but can you tell what squared is?
What is squared? Wait, I didn't get to the 11 yet. You want to hear about the 11 or no?
Yeah, let's do one at a time.
Yeah, let's hear the 11. And then we can hear about what the quared is. Quagmire.
Quared? Anyway, that's the velocity. Anyway, so you need to. I actually don't have the equation in front of me. Anyway, but you need to. So the velocity at infinity is 0. So you want to integrate from infinity until the radius of the Earth. Right?
And that's like what's the English word for it? It's like the borders. I don't know the English word for it. But
Yes.
It's like the those things that you write at the edges of the integral.
Yes.
One of them is infinity. The other one is the radius of the Earth. Did I get that right?
Yes.
Okay. So you subtract the two, and what's infinity minus radius of the Earth?
But at infinity is gm over r. It's 0. So that drops out.
Infinity is gm over r. Okay.
I mean,
Nailed it.
It's over r. Either way, it's over r. So you plug in infinity. So of course the velocity. I mean, I actually need to write this paper. So it's a good question you're asking. But anyway, let me see. The velocity. No, stop. I did this a long time ago. Look, no one asked me these questions. Finally, somebody's asking me good questions.
Genius.
You're welcome.
You know what, Peter? I like this guy. He's in just a few
strokes of the pen.
A few strokes of the keyboard, a couple of graphs, a title, an abstract, and a bibliography. He's already done more work towards writing a paper than any flat earther for the last century.
That is true.
You cannot argue with that.
I'm not. Look,
I would even say he wrote
By the way-
11 times more than what they wrote.
By the way, the word I was looking for, I just put it into Google Translate. It's limits of integration. That was what I was looking for.
Okay.
So infinity is the upper bound, right? And
It's
then the radius
from
of the
you
Earth is the lower
integrate
bound.
from infinity to the radius of the Earth.
From infinity to the radius of the Earth.
I mean, you put a test particle. You
So
want to
mean
know
infinity is the lower bound?
Look, you want to put a test particle at infinity, right? You have Earth. You empty, right? You start from an empty universe. You put Earth at the center of the universe, and then you take a test particle. You put it at the distance infinite from Earth, and you let it go. So it starts accelerating towards the Earth. And the question is, what velocity does it reach when it impacts the surface of the Earth? Right? This is, you should be able to do this math, and you'll get I got 11 kilometers a second.
You're talking about improper integrals. Sounds like.
What do you
where
mean?
one of the bounds is infinity or negative infinity. That works either way.
No, it's positive infinity, but whatever. But
yeah, okay, that's the upper bound then.
Anyway, but you should agree that it's some number, right? If you take a test particle and you let it go at infinity, you'll get, right? It's going to reach Earth at some velocity. So whatever you get, I got 11 kilometers a second. Whatever you get, you get. That's the speed of the ether. Because like in my universe, there is an ether that is obeying Newton's. The ether obeys Newton.
It's quite groundbreaking.
Oh, so what about cosmic radiation then coming to Earth?
What about it?
It's also ether.
Or meteorites. I mean, you should play a part in this as well.
Look, everything we see is just ether, right? So light.
I think I'm catching up.
Light, according to Maxwell, is waves in ether. Gravitational waves are waves in the ether. Like an electron is a wave in the ether.
I love it, man.
I'm not disagreeing with mainstream physics. I'm just reinterpreting. I'm just saying everything is ether. There's no disagreement.
I told you we agree. I told you at the very beginning. Here's a slide about ether waves, okay? We all agree.
It's just that, like, my ether predicts a constant speed of light. So
Is your ether different from my ether?
This guy is so stoned. It's funny to me.
Is he stoned?
I'm not.
Oh, he's talking. Is he talking about the ether they used in medical things earlier on?
Recreational ether.
Oh my god, you guys are killing me. Oh my god, you guys are so...
I mean, man, we're jealous, okay?
He's killing you.
Could be stoned this year.
I'm actually jealous
guys.
right now.
I think we got a report coming in of an attempted murder. He just said someone's killing him. What's happening?
This guy is like finding anything funny right now.
Oh my god, you guys.
That's the best thing about
You
being
guys
stoned.
are the best. This is the best server ever.
You're cool too.
Anyway,
if this is a practical joke, it's one of the best one I've ever seen.
No, it's not a practical joke.
Just copied that image onto every page on this paper.
I like the drawing.
What image? Which
The drawings are nice.
Which image?
Hello?
Hey guys, wouldn't it be awesome to talk to Bev one time when he is stoned? Maybe he's a completely different person.
Oh, no, absolutely not. I think he'll break through bad.
I think I think what's actually happening is that when Bev comes in here, he's drunk. Like when he's sober, he's just a completely normal dude, and he doesn't remember any of this.
As soon as he wakes up in the morning.
Yeah, he just forgets all of it, and he's just a completely regular dude.
Oh my God.
But he only comes in here when he's drunk. Kind of like Johnny B, actually.
I'm getting free laughs right now. I think that's a try.
Oh my God, you guys are so funny.
Hey, Mr. Slave.
Yeah.
Pudding.
What? Pudding?
No. Yeah.
Anyway, I'm hungry. I gotta go eat.
Maybe another time.
Ah, I told you he was stoned. He was munchies.
No, I'm not stoned. I don't do drugs. No, I'm.
Hey, marijuana is not drugs. It's just an herb, man. It's just ether in herbal form.
Anyway, look. The question is,
Inhale that ether,
let me ask you a
brother.
question.
Inhale it.
So, according to you, the speed of light is a constant. So why is the speed of light a constant?
It has to be.
Why?
The God made it. God made it this way. We don't know why. It's just
So
has to be.
but if you assume ether, then you get a constant speed of light.
But we already have a constant speed of light. Thank you very much.
But you don't have a reason for it. It's for you. It's a
Yeah. The
cosmic.
reason, okay. What's the reason for ether?
So I don't. Right?
What's
No.
the reason for ether?
No. We didn't. We used. Wait. Yeah. That's. I mean, we don't disagree on anything except for my
I told you we didn't disagree.
No. Hold on. Look. My universe and your universe are identical, except for you don't account for the speed of light, and I do. Right? We both
we do.
agree. We don't have a disagreement about the ether. You don't have an argument against the ether, right? You said yourself, I just rename things, right? So we don't disagree on facts.
No, we don't.
Okay. Nevertheless, I can predict the speed of light to be a constant, and you don't. You have to postulate it. You have to posit. I can prove it. For me, it's a conclusion.
We can predict it using Maxwell's equations.
No, you can't.
Yeah.
Wait.
That's what proves it. You're using the same argument.
But that assumes ether. I mean,
sure. That's why we love ether. We're ether fanatics. Actually.
Look, if you don't, I mean, your universe makes no sense. Without ether, your universe makes no sense.
Dude, I gave you a whole video, a whole slide deck explaining why we love ether. You know why Alan banned all of us? Because we are more ether than he is. He's jealous that we're more ether lovers than he could ever be. Okay?
Stop.
So you're preaching to the choir here.
No, stop.
The only issue we take with your paper is what Yui explained, and these are the kind of formal concerns regarding how it's written. And so I'm telling you, run a spell check, fix up some of the spelling, maybe invest some time in GeoGebra, instead of Microsoft Paint, and save to PDF and publish.
Yeah, we're actually in the ether.
It uses Microsoft Paint.
So just save to PDF, okay, publish, peer review, we'll see what happens. But it's good to go, man. It's good to go.
I'm actually the president of the Ether fan club, if you didn't know.
The Ether Foundation.
Yeah,
This is gonna be big when it's completed and hits the flat Earth scene. They're gonna be.
It's big if true. Big if true.
Yeah.
Anyway,
have you seen your paper recently? What's your name, Mr. Slave?
What's the question?
Have you seen your paper recently? Have you looked at it in the last?
Yeah,
hour?
I looked at it and I laughed. It's really funny.
Do you think you could maybe list some of us as contributors? Not co-authors, obviously, but contributors.
Yeah, I mean, honestly, I did more to save this paper in 5 minutes than anything anyone else has done.
Also, this feedback doesn't come for free.
Yeah.
Wait, can you? But okay. So you actually made a fair comment. You said if the speed of the ether, you said something like how does the gravity actually work? Right? You asked that like.
Somebody did.
So the
one of the voices in your head asked that question. Yeah.
Stop. Anyway.
Well, you don't see us, so we're just voices in your head, and you're high, and you cannot tell us apart.
Anyway, do you have any further questions about my ether model? It's like I don't think
No, I have one question.
No.
Could we make the speed of ether 11.1? Could you maybe recalculate?
11.1 what? Cows? Bananas?
No, kilometers per second.
Oh, okay.
Anyway, look, my point is, you don't have a fair objection to the ether theory.
No.
As you said, it's just a renaming, but
yeah, we love ether.
Okay. Anyway,
Well done. Good work, everybody.
So if Michelson, if I produce one of my experiments, I plan to reproduce or to actually fix Michelson and Morley, would that convince you?
We're convinced already, but you could go to LIGO. It's an existing Michelson-Morley experiment.
No, it's not. It doesn't rotate. You need to rotate.
Oh, okay. All right. Well, let us know when you have it. Maybe draw some diagrams in Paint, and we will consult. Some of us are very mechanically inclined, like Mr. Schubill. He might even help you build one.
It's very expensive. I need 10 kilometers of optic fiber.
Yeah. Well, go Amazon.com.
It's 100,000. It's going to cost
quantity 10 kilometers.
$100,000. That's the cost just of the material.
You got to do what you got to do. It is what it is.
Anyway, I'm gonna go.
Maybe apply for a grant. Apply for a grant, research grant. Use your paper. I'm serious now. Update it. Spelling, structure, Microsoft Paint. Improve that. Then make the speed of ether 11.1.
Okay.
It's going to look better, more impressive. And then use that paper to apply for a grant.
Also, when you change the speed of the ether to 11.1 kilometers per second, add an error margin of 0.5. You just make it up, but it just looks more impressive when you do it.
I see.
Make sure it can, if you change the unit to feet, that it becomes
What's the
360.
point? Look, come on, stop. I told you. We can laugh, just don't waste my time. So stop.
Okay.
So, do you have actual feedback? Right? So
we gave you all the feedback. Look at the comments in the doc. We gave you like an hour of
I
our
know.
That was the free consultation.
I appreciate.
Go get a grant.
I appreciate.
Go get a grant to build the experiment, the fiber optic cable, and use a portion of the grant to reimburse us. Okay, for this consultation.
Oh my God, you're. What's the word? You are. There's a word.
I'm treating you seriously. Is that what you're trying to say?
Anyway,
I actually wanted to give more direct feedback to Mr. Slave.
What?
I think you're on the right tracks here.
All right, let's not lie to him. All right, let's not lie to him.
No, he's on the right tracks. I just think that there is the particular part in your paper, like the beginning of the first part. I think that's too abstract. You need more concreteness there.
You know, I'll say, Mrs. Slave, right? When I was a kid, right? How old are you, by the way?
I'm an old man.
All right. When I was a kid, I used to do this thing where I used to write books, right? Like, they were shit, right? They had no sense to them. The plot was all over the place, and I could barely spell, right? So, this seems like reminiscent of that, right? You are not going to be writing a paper. I am sorry. You may as well give up that dream right now, while you still can.
Okay, but
no disrespect to you, of course. I mean, but the real, I mean, to write a paper, you need to know how to write a paper, as in have read papers before, right?
Mm-hmm.
I mean, have you read a scientific paper before?
Sure, I've read many papers. Sure.
Is that like how you figured out what an abstract is?
Look,
earlier you said you didn't read. Yeah, you
question-
were watching YouTube videos.
No, I've read papers. No, the question is if you guys actually have like anything like interesting to say, like beyond.
This is interesting. Save yourself. Actually, no, you know what? I'll change my mind, right? I was going to say save yourself the time, but actually, I'll give you a month, right? Finish this paper, show me, so I can get some comedy out of it. It shows
No,
to
what he
Twitter as
actually
well.
what he actually wants to do is he wants to take your paper and take all the credit for it. He wants to steal your work.
That's true. Don't show me before you published it, of course, on Amazon.
Oh my god, you guys!
When you do publish it on Amazon, make sure you're like you've got to do some marketing, right? Because obviously you're not going to get it in a journal, right? So publish it on Amazon, and then put it under the category of like, I don't know, dildos or something. And so when people are looking for dildos, they'll see your paper on Ether Cosmology.
What is wrong with you people? Don't you have something better to do with your lives except for just?
We are globe gangsters.
No, I don't.
So look, listen now. Listen to me.
This is what we do.
you got. Okay.
What do you mean, you people?
Look, listen to me. So you have flat earthers coming to you. This is how you treat them. You're creating the problem. You're creating flat earthers because of how you treat people. You can't be so terrible. You have to be.
Well,
just a little
I
bit-
disagree.
Whoa.
I disagree. It's about seeing the lighter side of things, right?
No.
Flat earthers love me because, well, actually, no, that's not true. Flat earthers love Peter because he sees the lighter side of things.
No. You guys, it's okay to laugh a little bit, but you have to balance it with actual content and an actual.
Dude, check it out. You came here. We listened to you for an hour. We gave you free consultation. You got actual feedback from people who hold scientific or academic degrees. Okay. We told you we agree with you. We told you we look forward to working with you on your research after you obtain the grant. We told you what to do next. You haven't been muted a single time. Nobody called you any words, any names. I think it was a good experience considering this is internet and Discord, right?
Yeah, I mean, usually.
All right, you're welcome. You're welcome. Now go back to work. Go back to work. Implement feedback.
Peter,
and let us know how it goes.
Wait, Peter, why are you so mean? Stop being so mean.
Because I was born in Eastern Europe and it's in my blood.
Oh my
Yeah,
god.
he is pretty mean.
Yeah, Peter, you don't have to be like. Don't be so mean. Like we're all being lighthearted.
Dude, listen. Just for context, in the place where I was born, you would be on your way to the Gulag. Okay, already. So what you have experienced here is nothing compared to that.
Yeah. Off you go.
And we gave you a few hints that maybe you should double check.
Look, I'm happy that you gave me some feedback. I'd just be happier if you gave me more feedback and less. And let's cut down, the less feedback part, and let's dial up the feedback part. So I'm really curious about. So I'm not trying to. Right, I'm trying to agree with big physics, except for I'm just trying to fix the issue of the ether because Maxwell assumed ether, and Maxwell without ether makes no sense, and a vacuum makes no sense, and no, it does make sense.
Dude, listen.
Yes,
I've been working really hard to prevent the usual outcome here, which is 3 people chiming in with actually, and for 3 hours explaining to you every single detail. Instead, you got productive feedback, constructive feedback.
A little bit.
Why don't you go back to your document and start hammering at it? It's not going to write itself.
I will.
those GeoGebra diagrams are not going to make themselves.
What's a
Your grant
GeoGebra?
application is not going to write itself. Go and start doing that.
Wait,
Enough of the trolling, okay?
What is GeoGebra?
It's just something I like. You can use CAD, you can use whatever. Just don't use Paint.
No,
It's not
Peter.
going to look good.
No. Use Paint. Use Paint.
Yes,
use Comic Sans font, and make sure after every image, after every page, you have a little picture of Krusty the Frog in the bottom of the screen.
Everybody knows that the font choice of champions is Wingdings.
Yeah. So take that on board. Make sure you write your Make sure the bibliography's at the top, the title's in the middle, and the conclusions 3/4 of the way through.
The conclusions are missing.
Make sure that Oh wow, Scooby.
Oh my god, you guys!
I put in references all over the place instead of just summarize that at the end.
Yeah, exactly. Don't put a bit. Forget the bibliography. Just write the whole fucking reference in the middle of the sentence. Do that.
Oh my god!
And also, every time you write the letter "the," write it 2 times.
Date it for like 1 year ago, so people think you've been working on this for a while.
Oh my god!
And whenever you write a full stop or a comma, make sure there's a space before it. Everybody knows that the right way to write punctuation is you put a space before every comma.
And double spaces between sentences, right?
Well,
Ed would get very mad at you. Where's
Ed? You know what? I'll just go full force and just make the text white so we can't read it. That would be honestly the best thing you could do.
Actually, what I would do is actually just write 1 word per page.
Yeah, that's also there.
That is a way to get page count. Yeah,
I do remember a friend in my primary school who did literally write 1 word per page. He filled his textbooks up pretty quick. With anything, I don't know. Like, it was like write the word "the," and he just wrote "the" like on the entire page.
Anyway, I'm gonna go. I'll come back later because I'm hungry.
You have a good day. Take on board what we said.
What?
Take on board what we said. Off you go.
No, for sure. And I told you, I spoke to Lionsgate. Lionsgate? What's his name? Lionheart?
Yeah.
If you were talking to Lionsgate, I think they might be, looking to put your production into movies.
Oh god, I was thinking that you were so much quicker than me on that one.
Definitely. Just make sure
it's a movie script.
Just be sure to retain merchandising rights. Okay.
Yes.
It
must be a movie script then.
Oh my god!
Hey guys, how are we gonna make an ether plushie? What would that look like?
Anything.
Okay,
before the week is out, we gotta have a whole toy line ready to go. Get on it.
Oh my god!
All right, Mrs. Slave, take on board what we said. Off you go. Keep writing. Let us know how it goes.
No, I'll
come back to us tomorrow. See what you've done.
Okay.
Tell us when it's published.
Yeah.
Okay.
Yeah. And send it off for peer review as well.
Actually, you don't need to tell us when it's published because we'll notice the scientific revolution happening when it does get published.
Wait, I've got one more piece of advice.
Yeah.
Right, okay, so according to Google, the worst community college in the country is Cloud County Community College. Make sure you ask them to read your paper when you want to get it peer reviewed. Then you'll be off to a winner. Cloud County Community College.
Okay.
Where's that? In Minnesota?
In Kansas.
Nice. It's really interesting that this is your reaction. Really interesting.
Yeah.
What, you mean that we treated you seriously?
Could you imagine why?
I mean, I think if I interacted with any one of you one-on-one, it would have been productive. But since it's like it's a gangbang, and since it's like a dog pile that you guys are you're not noticing that you like. I mean, at the end of the day, I mean, it's really funny, but I think if we ever interact one-on-one, it would be productive. I mean, this was very funny. It's good. It's like I really obviously had a good time, a good laugh. But I'm also trying to be productive, and I do really want feedback, and I do really want.
Yeah, but you got to think about this, Mr. Slave. If you're genuinely wanting to be productive, right?
Yeah.
You should. And I'm going to be serious for a second. I'm going to
Mhm.
give you what you want.
Mhm.
You've been given enough information. If we gave you any more, you'd forget anyway. So why don't you do what we've already said and then come back later?
I'll tell you the truth.
And also, Mr. Slade, you won't be able to interact with me one-on-one because I never go anywhere without my friend Yui. But I'm sure Omnivore will indulge you.
Absolutely.
I
He'll do anything for $10.
I already had a one-on-one with
Anything.
Omnivore.
Anything.
With Omnivore, we spoke yesterday. It was a good conversation. I think, I mean, if any one of you wants to have a one-on-one, maybe on my server, can I put a link to my server? Or is that...
Mr. Slave, you can DM me whenever you want about your ether stuff, and I will respond.
I was gonna like really throw someone, put someone in the firing line, but I couldn't think about who. You know what you should do, Mr. Slave?
What?
Pop up to a guy called Manufactotum every day for like every hour of the day, and just ask him to keep looking at your paper. Just do it all the time, even if he says stop. Just keep doing it.
I'll do it. I'll do it voluntarily.
What are you talking about?
Don't worry about it.
Anyway.
And if he blocks you, make sure to send it to his address.
Yeah, make an alt account. Try again.
Anyway,
when he blocks you, he's doing that just.
Manufactorum blocks people?
I don't think so, mate. Jerry would be a good one. How about that?
Oh, Jerry and Chad.
Yeah.
Yeah, send it to them.
Look.
Maybe Bev. I think Bev would really like to hear that.
Wait, Bev? You know Bev? Bev from
Yeah, he's my best friend.
From Britain.
Yeah.
We're drinking buddies.
From England.
From England, yeah.
Yeah.
It's the Bev.
Bev
himself.
All
Bev-
horizontals
what's the name?
are parallel.
Exactly, the vertical, yeah.
Yeah.
Wait, do you get along with him?
Oh,
Yeah.
I'm drinking with him every night.
Wait,
I
you're in
just came back
London?
from drinking with him, by the way.
You're in England? Are you in England?
No, I'm in the Netherlands. I just travel very far
Well,
to go meet him.
He's actually right next to me right now, Mr. Slave. Here, I'll get him on the mic. Hey, Bev, come over here.
Well, all horizontals are parallel.
Oh, I mean, that's right. He doesn't want to come on the mic. He's a
Nailed
bit
it.
far away.
You know, Bev.
Oh, he's a little shy.
But you
when
know
he's with
that
friends.
Bev simply believes in God. I mean, his server is just about believing in God.
Hey, Yui, was that a clip of Bev or was that your voice act?
That was my Did My Smokers Northern accent, yeah.
Man, you're good. Can you do it again? Seriously.
Let me try another one. Let me think what we're going to say.
You sound like Bo Selector.
There are no globe proofs, are there?
Very good. That's
That was good.
really good. That's really good.
Okay, now, hold on. I'm genuinely concerned. Did you kidnap Bev?
Hey, he's in my
You're
house right
pretending to be him now.
Bev, he's all right, yeah.
I think
Exactly,
when Bev left the
exactly.
server, he left the server, but we don't need him. You can
Yeah,
be
you got
our
me.
Bev.
Yeah.
Can you do Bo
guys.
Selector?
Wait,
Can't do that.
I'm gonna go eat and come back in like an hour or two. Are people
Yeah,
gonna
take a nap. You're high. Take a nice, eat something sweet.
stop?
Take a nice
Peter.
long lap.
Peter, stop.
And then
Write a
back
few
to
more
work.
sentences in your paper while you're eating as well.
Well, I decided to stop writing sentences and just do the diagrams.
Okay, you can do a few diagrams then while you eat.
A picture is worth more than 1,000 words.
Yeah, and it's much easier.
Just stay off the edibles.
I'm not taking anything. I'm just I
Don't eat. Yeah.
Look,
Don't
I'm
eat the
not
crayons.
high. You guys were really funny. It was a really.
You're high and we're jealous.
Yep, great.
I'm not high. You guys have been really funny, and it was really great. But okay, next time I'm gonna know not to. I want more feedback. So Does anybody want to do a one-on-one?
Bloody hell! Just go and have your dinner. Fucking hell.
We don't want to do one-on-one because because all of us have different backgrounds, so that's why we stick together to complement each other.
So no one here wants to have a one-on-one and talk.
We're like wolves. We're nothing when alone. We
Yeah.
walk in packs.
Exactly. You have to confront the pack, the whole pack.
Okay. All right. Anyway, I'm going. I'll see you later. Thank you for now. Bye.
Have a good day.
Oh my God, that was so funny. Holy Jesus, that was so funny. Okay, we've been here for 6 hours. Is the audio still good? Is it still running? Let me check. Britain.
Yeah.
We're drinking buddies.
From England. Yeah, okay, the audio is good. Oh, they have the comments here. 6 kilometers a second is way above the tolerance of the instrument. Right. We all know you're a troll. Mike Jones. Lol, I got you, man. Who is talking? Who is that? That's so funny. Wait, let me see the comments here. So this is, wow, look at that. Anyway, so he says, Ella, I got you banned, Mike Jones. I don't know who Mike Jones is. All right, guys, I'm gonna go. I'm starving. I'll talk to you later. Bye.